morning and welcome. Uh, just got back in from letting all the animals back in. Getting my coffee of the day going. Hope you guys can see me well. Check and see how the stream's looking. Everything looks good on my end. Let's switch the music up. Twitch is looking good and not so much for YouTube. Restream says everything's working though. Interesting. Let me try and see if I can go to it this way. There we go. Okay, so it looks like YouTube is working after all. It's just, to be expected. The YouTube Studio stuff that lets me live view these things isn't working. Alright, looks like everything is up and running. We should be good. Where did we leave off? I did a little bit of work last night, off stream. I took our, speaking of, I didn't push this, so let me grab this, migrate this to a different file. This was just the notes we put together when we were brainstorming stuff. Alright, that should fix that problem. Okay, so let me pull down the changes I made last night. I was not working on my laptop. Let me just make sure I got all of them. Okay, yeah. Alright, so last night I made a few changes. I'm not sure if any of them work. Well, I can code on my laptop. I am running into issues running it just because it's running WSL, because Windows. The drivers for my laptop on Linux are non-existent, uh, which wouldn't normally be much of an issue. You can just work around it for the most part with Linux, except it's got an embedded APU with an dedicated GPU, so it does the whole like GPU switching thing, and there's no official driver support for it from either the laptop manufacturer or from AMD, because it's got an AMD graphics card and CPU in it. Which is unfortunate because the last time I tried to do that with a laptop that had both graphics cards and relied on graphics switching, it just bricked everything. So I'm just unwilling to risk it. Um, as such, when I am coding on my laptop, I don't get to test things. Um, the changes we made, that list of interfaces that we came up with, are all now coded in. So they're not fully flushed out or anything, but they should be, and some of them still have blocks of comments in the relevant files, but the bulk of the work we put together is in now, at least from the class and interface standpoint. So before we jump too far into this, let's start by seeing if that will all compile and run. So let me remember how to move this panel real quick. Alright, we should be able to make, build, debug. I don't like that. get the feeling this has something to do with changing our C version. So make clean, make build debug. Let me see if that'll fix it. I thought that might be the case. I did find out running on WSL that the max version of a lot of libraries were significantly lower. Um, so on my full Linux build, which is what we stream on and everything, um, I get the latest of everything. So if I run, this is when I ran into an issue with autocomp version. Was it conf or config? Yeah, autocomp 2.72 or 2.72. This is the latest version of this library, the latest published version. It's like 24 months old. Yeah, the latest version hasn't been updated in 2 years. The version on WSL that it is locked to as the latest version, and you cannot, in order to install a newer version, you have to build it from source, which is what I had to do last night. In order to get a newer version than 2.69, which is what it's locked to, you have to build it by source. 2.69 was released like 7 years ago, maybe 5 years ago. And so that's what WSL is locked to, which is a nightmare. But I fixed that. I was able to get the build running. I can't see anything because WSL won't launch the window, so I need to fiddle with that and see if I can get it. Maybe I can do a toggle or something to get it to trigger those drivers on WSL. I'm not sure. I'll play with it. The so this is all working. So we should be able to one button. I don't like that. That should have ran. Let's do our full load. So the latest version of C. This is the other thing I had to downgrade was the compiler version. Oh, not GCC, G++. I'm pretty sure this was 22. Let me pop open GitHub. One button. Was 3.22. Alright, so make clean. See if that fixes it or if it's something else that broke it. It is something else. What else did I change? I don't think I changed anything in there. Let me just check our. I'll show you guys what I'm working on. go to our commits. Let's see what all was changed. This might be our culprit. None of these header files should have made a difference. They are linked to each other, but they're not linked to the main. So the only thing that could have made a difference was this, which is, it's possible this is what's breaking it. Let's see. We're just gonna, for simplicity, drag that out of there. Oops. Move. Great. So it's making this, then it's making this, then it's making this. It is making our main. That was not our underlying problem. We are getting a build asset, so that's not the problem. We're just unable to run it. Interesting. Maybe if I run it through here, we'll get something a little more useful out of than no logging at all. Same issue. Huh. Yeah. I don't understand why we're having this kind of the worst part is there's no, like, nothing. No logs, nothing. Just silent failure. We didn't run it after the last set of changes we had locally. So maybe we have something in this commit. See, this is where I downgraded the C version. I mean, the only thing I fixed here was some formatting stuff that I didn't like. I'm gonna go ahead and say it's not in our markdown file. We know this was working, and we know this was working. I wonder if we just migrate that back in there and then hop down to Alright, so let's clean the view up a little bit here. Okay, so our handle event and our render frames are still linked, which calls screen manager's render frame, which should be instantiated. So just to test this, I want to make sure. Yes, we started it yesterday. The technically we started it Friday. For some of it, but we pivoted projects yesterday and ripped out the essentially we renamed some things, and that was all that's changed. There wasn't really anything in there to begin with. We'd scaffolded out a project, and then I decided to start up the one button game jam. And so yesterday we went through and figured out what we're going to build, and then I created some interfaces for to house all of our stuff and did some renaming, changing this to one button, stuff like that. And we were launching a window. And then between last night and today, we no longer can launch a window. All right, so render frame. Yeah, this is doing exactly what it should be doing. Screen manager. Let me grab that. For now, let's just close that out. So we are collecting the. I know, right? I know. Literally nothing changed except I added these header files. Not even all of these. These two are already there, which was all of our core logic. These unlinked header files are all that's changed since this was running. And then I downgraded the C++ version, although I tried undoing that and it didn't fix anything. So Screen Manager can take in a renderer and a game manager. That's all linking correctly. And then it establishes our font. On cleanup, it cleans up our font. This is a pointer reference, but it's not handled within here, so we don't need to do cleanup for our pointers within here. The rendering, so this should call render frame. So in the CMake lists, yes, it's the CMake version. But I don't know, it's weird. It From what I can tell, the C version is tied to, or sorry, the CMake version has a limitation on what can run from the compiler. So technically it's not changing the C++ version like you mentioned, but it just won't go above a certain version on the compiler. Which is why I thought maybe downgrading this from .22 to .16 would have caused it to switch to a different compiler version that would have triggered the errors, but no, it didn't. Everything else is set in here. The only other location that we have changes is here. Um, and I mean we can. It would make more sense to, I think, just rename something like that. Let me see if that'll fix it. I tried moving it, but it shouldn't make a difference because should be locked to VS Code. Yeah, go figure. Oh, I just noticed something. Clean is triggering a full build like I would expect. My build direction never actually went away. Make clean. I assume this is tied to, yeah, it's just the update thing. I mean, CMake has been annoying, but it hasn't really given me any direct issues. To be honest, it's confusing at times, but I haven't specifically had any issues tied directly to it. Um, but I also can't say with 100% certainty that this is CMake related or not. That's wild to me. Okay, well, interesting. Maybe if I. Okay, so we can get this line. So it is actually running things. That just tells me that it's not doing anything, which most likely means it's failing silently on one of these tasks. I'm also having some weird issues with just Linux today. I'm not sure what's going on, but like my browser tabs keep randomly dying. That's more of a Chrome thing than anything. But so if the music stops randomly, that's because the Chrome tab that's running my music just randomly died. Yeah, normally I wouldn't go this route so verbosely, but obviously something is silently failing at some point. I don't know where, and we're running out of spots where it could be failing that would cause it to not render. It's gonna be something stupid. I just know it. Tests. Okay. We are using main callbacks, which means that our loop should be tied to here. This one is going to spam. Well, we found out why it's not running. Yeah. Although anymore, it's not going to be copy paste problems. It's going to be, AI autocomplete just doing whatever the hell it feels like, even though it's irrelevant. Um, so it's not okay. So this flag is supposed to switch. It uses the internal main cycle within SDL, so you get your game loop just as this function instead of having to write the boilerplate for it. Very straightforward. Unfortunately, this should be running every tick of our game. It's not. So we're never calling our render because their iterate is never being called. That's a new one for me. That should only be happening in the case where we're not getting an app continue at some point, which I don't think we're running. Oh, this might be the reason. There we go. All right. So what's going on here is the last thing we did was to get it to compile last night. Um, was just kind of I filled in just like placeholder in this. Um, Unfortunately, without thinking, I just copied this and used the event that it was returning, and then just replaced it in here. Um, so SDL has a weird thing. I guess it's not weird. It's you get an initialization event before the first iteration cycle, and so we get an event saying initialize. We then tell it success, which is the like close code, like the program ran successfully, close. Um, and then it never calls iterate because it didn't have to, because it was already closed out. That is why we were getting no window showing at all. Okay, here we go. We're back to where we were. Okay, much better. So we shouldn't have to do a whole lot more with this main file anymore. We might need to make a couple more tweaks to how we're handling our game state, but for the most part, we should be good now. Exactly. Now we just continue forever. I want to start. Let's go this way. Design. We can just get rid of this. Actually, no. I want to keep this. For research purposes. We're good there. We are building for those that weren't there yesterday, that weren't able to join us yesterday, um, we are joining, we joined, it has already started, the one button game jam. So the one button game jam, which is an itch.io, started a few days ago, actually. Actually started a few days before we joined, so we're a late join on that one. Let me just grab this. Here we go. The concept behind the one button jam, which is, I think they did this one annually. I don't think this is a biannual. I think this is an annual one. The concept is that you get exactly one button as your user's way of interacting. So you can think stuff like um, uh, the side scrollers where the only action you can take is jump and you have to jump over obstacles, for example. That is one way of looking at it. The like auto runners fit into this category for the most part and stuff like that. But we get one button. Now we can use that button however we wish, which means that, yeah, the Google Chrome game, which I have somewhere. I have an old hoodie that has the Google Chrome logo on it, and I actually have some of official Google merch, like a USB and stuff like that, from an old Chrome Dev Summit I went to, that all have the 404 dyno on them. Anyways, that's the technical limitations of the game we're building. So we get one button, which complicates things while also simplifying. It simplifies our player controller, but as we're writing everything in C++, the player controller is one of the easiest things for me to build. So it doesn't really help us. It just complicates things. They gave us some themes: Worm, Typhoon, and Echo. We did some like mind mapping on Echo, and I eventually narrowed it down to the path we followed for this was actually I can pull that up as well. Let me just grab our board for that we did yesterday. So this is our game flow. Is this one? Yeah. So echo, repetition, repeating actions or events, which the first thing that comes to mind when you have repeating actions and events is roguelikes, which I then this technically wouldn't fit into this style of brainstorming, but my next thought on that was going down to scoping it by the one button. When you have roguelikes, you have things like it renders a few cards and you choose a card, and that's your next action that you take as the player. So this is what I wanted to go from a mechanical system. I then needed some sort of settings that leans into our Echo theme. And as I was thinking about this, the what I landed on was a roguelike simulation mashup. And so what I want to do is I want to have it to where like we're running because I couldn't think of a better one and I didn't want to iterate it on it for too long. We're doing essentially a trimmed down version of Game Dev Tycoon. If you guys have ever done or played Game Dev Tycoon, uh, it is a simulation game where you start off as a like solo developer in building your own indie studio, and you grow. You get to choose if you want to take on a contract, if you want to do like build an RPG, whatever. You pick the genre and those kinds of things. Then you build it and you see how it does and how it sells. And so that's the core concept of it. So it's a game developer simulation game. Is kind of the but it's more like a business simulation game. It just happens to be game dev. So I want to follow the same core principles from a like ideology standpoint on the you choose the game you want to build and then you it auto builds it for you. I want it to be slightly more involved than Game Dev Tycoon is because that's one of those games where you just kind of like choose the thing and then you just let it run and then you level up your characters and then once it's done then you choose your next one and let it run. I want it to have a more rogue-like feel. So a lot more aspects are going to be randomized. I wanted it to have a more involved gameplay loop. And so we'll do like a series of actions to progress the game, which every action taken will be through the card system. And so you'll get a random draw of cards. You'll select one of them, and that's how you progress on the core gameplay loop. So the way I'm in my mind, what it looks like would be the Game Dev Tycoon style of almost idle static asset style. Um, but the moment to moment would be kind of on akin to Slay the Spire almost. So it kind of fits into almost like a card battler. But instead of battling some enemy you ran into exploring a tower kind of thing, you are instead going through and um, progressing and building a game is kind of the goal. So that's kind of where we landed on topics, iterating through and trying to decide on what we to do last stream. And so I'm fairly happy with the direction that we're going to be taking on that so far. I like the concept. I like the um, just general idea behind it, but we don't know how that's going to feel just yet. I am getting a lot of issues with my tooling. Just to let you guys know, I'm I don't know if it's my browser that's kind of crapping itself or if it's the something with Restream, the tooling that's going on there or what. But I apologize if I miss any messages because I can't get them to consistently show through Restream and I can't always see them Here, let me see if I can even. I think it's my browser because even the stream chat for Twitch is having issues, and that one's historically pretty damn good. So we'll see. But yeah, so that's the direction we're kind of going here. Past this brainstorming session I did to figure out how I want to handle that, you can see I kind of filled this in. We're doing a roguelike simulation game. Right now it's just called the One Button Game Dev because naming is hard. But past that, I put together a just kind of game flow to help me organize things. We do want to introduce main menu stuff. That's kind of what this entry point is. We'll use the same selection system. I'm even going to go so far as to code it to utilize the same selector logic, and then our game loop. And so it's fairly straightforward. We'll go through a setup cycle where you would choose your roguelike modifiers for a run. So, reduced income, for example, or increased attrition for your game devs, stuff like that. Then we'll have what I'm dubbing the requirements gathering phase, which is where you would go through and you define your genre, define the systems. So like a MMORPG. This is where you choose what you're building. Technically, we could swap out the underlying theme and move it away from game dev, and it could be, insert whatever you want to build as a business sim style. And then we have what I'm just doing is the day-night cycle, which is during the day you make operational decisions, and at night you'll see the outcome of your decision, so that we have a tighter feedback loop. Upon completion of whatever your requirements gathering was, or the studio ran out of money and you got shut down, then we'll hit a conclusion point, which will have, payout, so you get to see how well you did. If we'll try and introduce a leveling system for the game devs you've hired. This is probably not going to make it. But then we'll have run unlocks, and so this is our per run difficulty scaling and inner run progression system. And it's a roguelike, so as soon as you finish a run, all progression is cleared. So it's a fresh restart. So this just kind of scales difficulty and unlocks, and this is where a lot of the variability comes from. And this, like everything else, will be a choice the player will make. And then it jumps back to the setup cycle. And so this will be the modifiers for your next run, so on and so forth. And then if you win or lose, then would transition to the post game, which just gives you stats, more or less. So that's kind of what we're working on right now. All right. But let's dive into it. Get my music going again. We don't need this anymore. We don't need that. This is where I was doing a lot of my brainstorming. And then this is kind of where we landed on a overall concept. There we go. Just so that's tracked still. Okay. So the first thing I want to do is I think we need to flush out the menu system, and that gives us our first chance to handle some of the basic textures. So let's do that. So we've got the game manager. We are going to set the initial state. Let me deal with that. Pop out chat. All right. We need to set our initial state. So let's initialize this to, nope, that. That's exactly what I want. And we can initialize it inline here to main menu. Perfect. And then we have our screen manager. I need to expose this publicly, I believe. So let's do that there. Let's do that. What is this? Static? Storage class. Is it? There was a way to handle this to where you can reference these retroactively, but that's fine. I can just do. So now we have game manager, game state. This has a game manager reference. So when we go to render frame, we can get game manager, game state. So we can get a reference to current state. Do you want current state? Yes, we need this. So let's actually make this public. In which case we don't need this. Do you want to make this read-only, which I don't know how to do in C++. Nah, I didn't really want to do it that way, but I guess we can. Proper way of handling this would be game state. We don't need that. And then here we can call, oh, also I want this to be const, okay, good. State, get current state, boom. Now we have a const reference to our state, which will prevent us from modifying it in any way, which is exactly what we want. We don't want to make any modifications to this. We can then use this in a switch case. So this will render background, it'll clear, so our switch will go here on state. And we'll have a case of game manager, game state, main menu. Yep. Let's do a default. All right. Yep. Don't break. All right. What did you inject for me? Placeholder rendering logic. Render out a rectangle. No, I do need that. I need this to be a pointer reference, I believe. No. What is your complaint? Oh, right. Frect. This will let us know if we're on the main menu or not, which is good enough for now. Let's run it. Hi. We know we're on the main menu. If I were to change this to be any state set except that, so settings menu, and run it, we shouldn't get the square. Perfect. All right. So from here, we need to implement our render logic. I want to implement all rendering for this into the screen manager. In order to handle that at scale, I think we need to break this into a series of functions with a container function. So let's make a void render main menu screen and then a void render screen. And so let's hop over here and we have this logic. So we're going to cut this and we're going to do a void render screen, which will take this and then it is going to get this block removed and it's going to call render main menu screen. And then we're going to void render main menu screen. All right. Our renderer should be getting passed in. Oh, right. We need to add screen manager, boom, boom. And then state gets set here as such. All right. There we go. Now we have a wrapper function that we can call to keep this logic as concise as possible. So this will handle any sort of logic that we need to run that is universal. So mainly this is going to focus on setup and destructuring. And then, do we even need to go that far? I guess I could put the entire switch case within here. It wouldn't make much of a difference. I don't think we need the double layer of abstraction, so yeah, let's do that. And then that allows us to remove render screen. The main reason we would want something like that as a secondary layer of abstraction is because we might need to do some sort of, like, this would probably make more sense to be in that render screen because it is the render, or sorry, at least this is the screen set up for the rendering, and then the actual render frame would contain this and that call. But I don't think it's going to expand much past adding additional cases, each calling their own subfunction here. In which case, I don't think we need to handle all that extra abstraction. We're not really going to get much of a benefit out of it. If we had a lot of logic going on in here that wasn't just a single switch case, then I guess it'd make sense. But I think at most we might introduce some timing stuff that gets passed around. But even then, I think we can call it directly within here. We don't have to. All right. We might add delta to these, which would be one line of logic, and then pass it to set a variable and then pass the variable. We'll see. So we now can perform the exact same logic, rendering out through this render function. How do we want to handle? We need to load in textures. We need to create our objects and reference them to textures. We don't want to have to recreate these every time. We want them to persist in memory, which means Screen Manager is going to have a lot of just texture coordination stuff going on in it. So let's start by creating a texture map. Actually, we don't want a texture map. We have order matters in rendering. I wonder if we should provide a Z. Doesn't matter. Let's start with GIMP. We're just going to do some blocks of color real quick. I just want to make sure our depth is set correctly. And that we can reuse references. Oh, we don't want a template. Let's do 800 by 600 is our background. In which case we want to, where'd my fill button go? I know the fill button's right here somewhere. Can I right click on it to add, remove? Nope. Is this it? I think that's my gradient tool. Maybe if I, nope, it doesn't, just need more room. Tools, paint tools, bucket fill. Let's change this to, let's use our blue color that we have set. Is that it? I think so. Save as, I'm going to make a coffee run soon. Right, I can't use save. I need to export. Projects, assets. Let's do menu, background. additionally need a .28 by 32. We'll call this I don't know, pick a color. Actually, I want this to be very obvious. And then this will become export. Menu, button, texture, export. All right, so that should give us the minimum we need on textures. Discard. To get us started. We left a console log. Here, clean it up. All right, we should now have a texture for our buttons, and we should have a texture for our backdrop for the menu. They are not our finalized textures, but they have high contrast, so we should make sure we can get our Z indexing correct for overlay. Maps, game state for game manager, connects SDL render to game. Okay, yep, we're already doing that. So we need our render main menu. We need this to now draw our textures. In order to do that, we don't want to have to pull in the texture every time. We should probably go about this with a caching system. Let's pull up the code we used for pulling in textures previously as a reference. Alright. I need this for a second. Is this the code we used for... Here's our render text. Render frame, I believe. Yeah, here's our load texture. So we can pretty much use this verbatim. So our screen manager will be responsible for loading textures. Do we want this to be responsible for loading textures? It's already going to be handling render logic. Let's create an entity manager. Oh, I also renamed objects to entities to be a little more consistent with how a game engine would run it. So let's we're going to call you entity manager.h, which is going to have a entity manager.cpp. In here, you're going to include entity manager.h. I swear, about half the time it makes my life harder. Okay, so we don't need to do anything with that just now. I do want to add our pragma once here, and then we'll import that. Nope, I want entity manager to have this, which is going to be a definition we're going to need to figure out. So you are entity, nope, class entity manager. you have a private method that will do the following. I don't need that. Load texture. It's going to take the renderer. We need renderer and file path. Does that cover our use case? I think that covers our use case. All right, let's throw that in. We need, there was another, not new state. Render text is something that's going to be required at some point in our screen manager. So let's go ahead and drop that in so I don't have to come back to it later. We need to handle So I feel like Entity Manager will need to handle loading of textures, caching of textures, and then assignment and creation of our entities so that they can just be referenced and reused by other services. And so I think that'll be enough to get us started. So if we go to Entity Manager now, I don't think we need this any longer. We are going to need include string. Should make that happy, which should make this happy. We are going to need to implement our texture cache. Oh, that's what I should have done. I should have, we can rebuild that. That's simple enough. The image load texture, we are going to need our include SDL3 image. Is it SDL3 slash SDL image? I think that's what it's supposed to be. I'm gonna fold it up. Nope, the first one was correct. We are going to need this at some point. Then I needed to look at this. Let's go ahead and grab the token cache, texture cache. Let's grab these. All right, that should get us a little ways through here. I just need to save it. There we go. All right, so let's think about this for a second. We want to be able to house a, nope, that's not what I want. We want to be able to house a lookup map for textures so that we don't need to reload textures. We need to house a I want to I'm wondering if we should even have this as entity manager because, well, we are going to need at some point a set of cards broken down by the card type. for total sets as well as available sets, we are going to need to be able to allocate those. We're going to be able to bind textures to them, position them on the screen, yada yada. Those are all things we're going to have to do. I want to be able to reuse our textures, which means that we want to link the cards to a texture cache reference. We want to be able to, and then reuse them. Oh, let me get some more coffee before we dive into this too much further. Give me just a moment and I will be right back. And we're back. All right. So this, I think we just more or less keep as is. We change the how we're referencing these, but I think this just functions for us. The reason being is, and I think we renamed this texture manager. The reason being is this will allow us to load in all of the textures that we are going to require, which aren't, there's not going to be many, and then provide a enum to be able to reference our textures, and we can just do lookups based on the enum. So let's create a public struct. We are going to use texture name. This is not a struct, this is an enum. That's not what we're calling it. For now we have menu background and menu button background. This is a reference between the texture name and an SDL texture. And so now we can, and then we'll need a, let's comment you out for now. You are a private method. Public method for, nope. We want you to be called, we do need that actually. It's not what we're looking to do right now. Destroy texture, yes, 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 yes. Let's try and use our to do, use unique pointer. Let's try and set this up with our first utilization of unique pointer. We need to get into this habit. This is going to save us a lot of headaches down the road. Outside of this, we need a lookup for get texture. There we go. All right, so this will give us our texture reference. This is a place for us to store textures. This is our internal function for loading textures in based on paths. So we can now create a series of calls. We need it to, wondering if we create this as a struct, we'll call you texture details. No. Let's just call it texture. Sure. So it takes in that. We then have a standard string file path. If we handle it this way, we can create a private, we can initialize this. This doesn't need to be a pointer. So if we initialize it as such, we can then create this statically. As such, which should solve a little bit of a issue that came to mind. We called you texture. That's fine. So now we can iterate through these and we can populate out our pointer references to our textures. which will give us a much smaller footprint. Yeah, let's do it that way. Okay, so we want to loop through now. We can do something like this. We can set, we did call it SDL texture. Yeah, SDL texture. We can set you to, I don't need to be in this file to do this. I specifically don't want to be in this file to do this. Let's grab this. Jump back over here. Remove that. Remove that. Our texture cache now has a, yep, nope, that, give it to me. There we go. We are going to paste that into here as well. There we go. All right, we need to iterate through taking in the renderer and a reference to a texture. No, let's take in a texture name. We can do the lookup on the texture, which means we do need to store in renderer. So let's grab how we do this on Screen Manager, point a reference to renderer. You're going to take in that. We need to store it via this. All right, and then we need to update this. Go. We need to we don't need to delete this because we're not creating it here. We'll come back to this in a moment. So this gives us a renderer reference, so we now have that, which means we don't need to pass in the renderer every time. When we create the entity manager, we will need to pass it in there, but that's fine. Okay, so now we have, all right, we need to update our, where's our load texture? Oh, here it is. This no longer takes that in. Come on, update. There we go. All right, so now we're taking in the texture. So we get a file path from the texture cache based on name. So this is now our file path. We can then create our PNG path based on construction of the string. So this is going to force all asset lookups, all texture loading will have to exist within the assets folder. We can then assign, this returns the SDL texture, right? Yeah, okay, so this is SDL texture. Assign the texture back into the texture cache. If it didn't load in, then we're going to throw an error, which will close out the app. We probably want to go ahead and add it to do. More gracefully handle this. We don't want to just fail. We should introduce a fallback texture. It'll look buggy and broken, but it's better than the app just crashing. Or at the very least, throw an error to the user so they know why we're closing things out. Free up the PNG path that we created, and then continue. Yeah, remember never to use success. So this will allow us to load in textures. We then want to, actually, I can simplify this slightly. If we return a, if we return a SDL texture reference, we can SDL underscore. Let's just do auto texture equals that. And then we can do a if not texture, return our error. And then in here we can do a try. We'll go back to that in a second. What's the namespace for that? I need to import something. I just don't know what it is off the top of my head. std accept. Yep, that one. That should it. There we go. So now we can throw exceptions, and then we free up the path, and then this becomes texture. We then need to update our header file to be in sync on that. This allows us to get a reference that we can modify on the name and texture from the texture cache. It is not name and texture. It is name and texture. This is capital T texture. This is our texture. This being the texture name. Yep. So there we go. And then we can set SDL texture equal to the load texture, iterating through. So that's all good. If we have a runtime error, then we had an error loading textures. And then we suppress to do. Let's handle error appropriately. That should put us in a slightly better spot. So we should be able to load in our textures now. We then assign them back into our texture map. We are not using any pointers anywhere we don't have to. When it comes to textures and renderers, we have to use it as a pointer. So we're kind of stuck on that one, but that's fine. We do need to do texture cleanup. So we'll loop through and do that. This works fine then, so we don't need to rework that. We don't need to use a unique pointer for any of this because it is all tied, all of our pointers are tied to the SDL stuff, which has specific functions for doing their cleanup. Since it's a standard pointer, we can return it. Let's take this a step further and not just destroy, but also texture null pointer. All right, that's looking good. And if we go here, we've got our map of textures, so we can just expand this over time, adding new texture names and then binding it to a path, and it will just load in the texture for us. Upside to this, super simple. Downside, it means we load all of our textures. Um, so at some point in time, I'm not sure if in entity manager. I'm not sure if the load their like loading of textures. I'm willing to bet this is not an asynchronous task. So and this has to happen on the main thread. So we might need to do look into async loading of textures. There we go. Let's see if there's something we can do to statically load some and asynchronously load others. That way we can, like, you're going to get dumped into the main menu when you start the game. So statically load main menu. But then in the background, we can start dynamically loading asynchronously all of the other remaining game textures to optimize for first load. All right, so now we have our textures being loaded in. I am going to rename this all to Texture Manager. Because we're actually not going to be doing any entity management within here. So Entity Manager is now renamed to Texture Manager here and renamed here. And then within this code, everywhere where we have Entity Manager, you are now going to be Texture Manager. These files are happy. I am going to need to instantiate this here. So we now have a texture manager. When we create our screen manager here, we also need to create a texture manager. The screen manager is going to need references to the texture manager. So we need renderer. Yeah, renderer, game manager, and then we will create a texture manager. You are going to include texture manager. This also needs to include texture manager. This now grabs a texture manager instance, passes along, solves that problem. This is taking in that, boom, 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 and then we need to add texture manager here. So now we have our texture manager reference being fed into the screen manager. This should allow us to populate in our textures by a reference so that we don't have to reload textures. And we also don't have to store them inside of our screen manager. We then need the intention is to have game manager house the sprites, which means game manager is also going to need a reference to texture manager so that we can get the appropriate textures when we're creating our sprites. You are going to need texture manager. You don't need renderer. We do want to store texture manager as a reference to the pointer. Then we need to include texture manager. That way that's all happy, which means then in main, our game manager's constructor now requires texture manager. There we go. So texture manager gets instantiated, which loads in all of our textures. Then we get game manager instantiated with a reference to texture manager, which would load in all of our, create all of our sprites that then reference the textures. And then our screen manager gets loaded in with references to the renderer, the game manager, and the texture manager so that it can take the game state and fetch any entities from that, and the texture manager to pull in any entities that are not sprites. Because we are going to have things like backgrounds and stuff like that. So Screen Manager is going to have to directly access some of those textures. Then, of course, it's going to need the Screen Manager is going to need the renderer to render. That's all looking good. Okay, so now our Screen Manager should have the context it needs to render out our background. Let's collapse that for now. Render main screen. All right. How did we render textures? I'm going to look that back up. There's going to be a lot of referencing our old code as we go until I do this enough that it becomes second nature. So it's going to be a minute. We want to go into render frame, render texture. Okay. All right, copy. All right, so when we go to render main screen, which is part of our render frame, we need to render a texture. This is going to be texture manager get texture for menu background. So this will give us our full background, which means we don't need to draw a const color. So let's do that. And then this is the source rectangle. If we provide nothing, it takes the entire texture. And then destination rectangle, if we provide nothing, it fills the entire screen. So this should render our background across the entire screen as the first draw render. Extra qualification on member load texture. Load texture within texture manager. Oh, I bet it's in here. I bet we have, yep. Just need to remove that. There's our texture. All right, so now we need to create menu buttons, but we don't want to recreate them every time we draw. That would be insane. So we are going to need to store menu buttons with click-through actions, I think is the way we do that. I think this is part of Game Manager. So if we go into Game Manager, we have all of our game states. I think this is where we start creating and managing our entities. And so we can create a yeah, let's create this as a entity. No, it's going to be a we have an ordered map. We do. Okay, so standard unordered map. We're going to take in a map of game state to vector. Do we want it as a vector? Yes, we want it as a vector because that one we can determine render order entity. This needs to be standard. Entity will have to be imported. Boom. Game entities. We then can include entity. So this will allow us to take our current game state and map it to a vector of entities. We're using a vector of entities because this is the C++ version of arrays, and so we can iterate through them in a set order consistently, which is important for us because we can change, if we change the order that we render to the screen, we can change depth. And so let me see if I can find an example of this. I don't know if we're going to be able to find an example of this. Here we go. Here's one. This might be a little hard to see. Let me see if I can zoom in. There we go. So this is a common problem when dealing with 2D. The order in which you draw your textures to the screen, when we're in our case, it's going to be purely based on the order we draw them to the screen. The order of that vector will determine the order things get drawn. And because of that, it means that we just need to swap our this tree texture and our sprite texture's position in the array, and we can get them to overlap how we would want or inconsistently, however we want to do it. When we're dealing with a game engine, there are built-in ways to handle this. You just need to know to trigger them. So it's not like it's impossible to do outside of this. It's just going to be a little bit easier for us because we know, we're effectively providing a z-index. We can sort arrays based on y value if we wanted before we render or after we perform an update. Or, yeah, because if we're effectively functioning in a 2D grid on the screen in our render position, all we need to know, because again, we're in 2D, all we need to know is the Y position in this style of 2.5D, and we would be able to just sort on that, and boom, our rendering is fixed for that. In our game's case, we are overlaying these as like menu style, so it's more of just background gets added to the vector first, and then things like, HUD, then our cards, and so on and so forth. So it's going to be a little bit easier for us. But this would handle it in this situation as well, so we can reuse this entity style approach in future games where we want to start doing like 2D grids with character movement and stuff like that. So that's why we want to use a vector here, is it just makes it easy for us to sort and handle this down the road. Okay. We can create this one. We might not want to do inline, but we can. So we can create a main menu, then we can create a vector array. So it would be entity. When we load in the entities, we need a reference to the texture. We can't do it here. Let's move our logic for this out of the header file and into a game manager.cpp. Boom. We don't need to do anything with this right now because we're not creating any new. This would be handled as part of our main file. Let me make sure I've added the cleanup code for that. Main. Do we add a new texture? Yeah, so delete. Okay, just making sure. Alright, so we need to load in, for main menu to render correctly, we need to load in our buttons. So let's go through and just do a, what do we call it? We called it game entities. Right. We need to handle this as, that's not what I wanted. Right? No, we need to bring this in one more. This should be, this import vector? It does, okay. I don't think I need to use new on a vector. Normally I would handle this, if I saw something like this, I would do it as const, but let's come back to that. Let's fix the other errors first. Oh, alright. That's what I need. So I don't want that. I mean, technically, we could remove all references to texture by just always adding our background as the first texture. What do I think about that? That would probably actually be better for us if we did it this way. So let's do that, which means in Screen Manager, this just got a little more simple in that we no longer need, where'd it go? Oh, right. We no longer need this tied in. We can use that. We just need to take in all of our texture objects from the, yeah, yeah. So we just feed this vector into Screen Manager. Okay, so I think we're going to have to refine our entity objects slightly because we have the texture reference, that's fine. This positional reference was intended to be the screen position. And if we look at Screen Manager here, this becomes an option for us. We can pass null here. It means we have to handle this as a pointer though. Are we using pointers in entity? I don't think we are. No. If we change this to a pointer, we can set this to null. This can become, we'll come back to that in a second. We need two of these rects now. One is position, and the other one is, they call them source and destination. Position is going to be our where we're rendering it onto the screen, so that it is our render position. Which means we'll call this the, there's a name for this. call it screen position and texture position. These are called sprite maps. Technically, it's a combination of the texture map coordinates and size. What do I want to call this? It's slightly important because if we don't get it named quite right and we have to look it up every time we want to use it, it's going to be pretty damn tedious. Um, so our entity has a texture. I like position here. I don't really like source though. Also, when we extend this, our position might or might not change, but our when we start doing the sprites, for example, our animation map does change. What I'm concerned about here is this would hold true even in our sprite case, but the source that we're pulling in here would then be utilized as our animation map. So we're no longer using this variable. I guess we can still use it as like a default. Like if we ever try and do a animated sprite and we failed to initialize the animation map, at least it would have a fallback and not just show the entire like animated sprite sheet. So effectively, our animations would stop and it would go into its static form instead of just trying to dump out 30 pictures into a tiny little square on the screen. So maybe we would still want to use this approach. This means that we need to change this to be a point of reference as well. We are going to need to do, we don't need to destroy textures anymore because textures are handled through something else. But we do need to destroy. Yeah, we are going to want to clean up our if source, please source. Yes, actually, I want this. Source position. So positions where we're rendering onto the screen, and sources, the rectangle we're getting the position for. We no longer want to do it this way. We now have a pointer reference, which means nope, this is our new entity structure. That should work fine for what we want to do. And then in here, we are now going to have a destructuring that's going to have to loop through our animation map, grabbing all of our frames, delete frame, null pointer. Let's set it equal to null, not null pointer. do. There we go. That should be fine. This will do our cleanup for our animation map since we changed this over to be pointers. We don't want to use. Do we need to return this? Do we care? If an entity can render itself, entities don't need to render. So the reason we're not using unique pointers is because these would actually have to be shared pointers because we are sharing the pointer reference. So unless we want to move this out of here and then move it back in later, we would use shared pointers instead of unique pointers. Shared pointers come with a cost overhead, or like a performance overhead, which is why I'm just deleting and doing cleanup. Like in cut and dry cases like this, where when this is destroyed, we destroy the pointer references. It's not a complex situation. Um, it's easier to just go ahead and do the cleanup and use regular pointers. I would like to use unique pointers. It's a little more safety. However, you cannot share unique pointers, therefore I'm doing it this way. If we migrate the render logic into our entity object, if we have a, render, whatever kind of thing here, we call SDL, we perform the rendering, we place it, yada yada. Our screen manager just needs to loop through our vector calling render on all of them, passing in the render reference so that it can do its thing. However, which in a lot of cases works fine. We don't have to worry about it in most cases. For our game, we can run this all on a single thread and we wouldn't have an issue. However, if we ever wanted to support the case where we have where we migrate our logic off of the main thread for handling our entity positional updates, telling which animation should be run next to just kind of reduce it so that our main thread is all that interfaces with it. Just all it does is render logic. It doesn't have to do any calculations above and beyond that. Just literally calls render and sends data to the GPU to optimize on our performance there, and then would of course have to handle the event bindings because SDL. We cannot run SDL renderer logic on anything but the main thread. It's a limitation of SDL, which means if we add a render function here, we're having to pass our vector array across the thread boundary, which means that the entirety of the entity's array, this isn't storing everything. So if our sprite is a pointer, we can pass the memory reference, which is essentially what a pointer is. It's just it points to a location in memory. We can pass that across the CPU boundary, and then, or sorry, across the thread boundary, and then the main thread would be able to just pick up the information stored at that pointer location. So I guess that wouldn't be too bad actually. So maybe we do want to incorporate a render function in here. It's going to be void render. Takes in the renderer, calls SDL's render texture. Let me make sure that our screen manager render texture. It takes in a renderer. It takes in its texture, and then its source and position. That's all it has to do. Does it even return anything? It returns true or false on whether or not the renderer succeeded. So I guess I could bool return. I don't even know if it's worth creating a CPP file for entity when it's the entire logic is this in this one line. I should. It's just such a small amount of logic to separate out of into two files. But this gives us a renderer. And so now in our sprite, we need to overload renderer to cycle through our animation map. We'll handle that down the road. We're not using sprites yet. All right. We now need to store game manager. What are you complaining about? Entity matches argument list. I'm importing entity, just making sure. We need to update what our reference looks like here. We want background. And we want null. Null. Let's jump into entity. Are we? Nope. We need to duplicate this. You are source. Okay, so that is our assignment. Okay, now we should be able to background null null, and then this one can get the button background, which is 300. This is incorrect. This is correct though. No, neither of these are correct. We want this to be null so that it fetches the entire image. Like we want the entire image to be stored in as our texture. And then we want to position it, should be XY, which means inset from the left. Wow. Fine, whatever. We'll just leave it as is. We'll adjust this later. And then we made ours. Is it width then height? Width then height. Okay. So we made it 128 wide and 32 tall. This is the default texture. I need to go to the bathroom real quick and stretch. I'm starting to get a little achy, but I'll be right back. And we're back. Okay. So I'm thinking we're gonna have to make some edits to this to support our selection states as well. Although I don't think it belongs within our entity object, which would be the easiest spot to store it. I think we're just going to need to update our game entities map to maintain that as well. Okay, so actually, I think for entity, I think entity here is fine. This one's our problem. Let's go ahead and render this and see if it's doing what we want it to do, though. Let's start there. It's not overlay. Oh, right, because we didn't update. Interesting. Double free or corruption. That's not good. That means that in our game manager, we are not correctly freeing up our memory. Texture manager, so we're taking in our entity here, we're creating, okay, so entity, if source, delete source, if position, it does not need to clean up the texture because texture should be getting handled by texture manager. We were seeing an error saying double free or corruption. I'm wondering if this is causing us issues. So let's run it and see. No. Okay. That is not our underlying problem. We are not calling SDL quit anywhere else, are we? No. Game state is being deleted after we destroy the renderer in a window. Let's move these into our game states destructor. Okay. Game manager, screen manager, texture manager all get deleted. Let's assign them all to null pointers. Game manager equals a null pointer. This is screen manager equals null pointer, and texture manager equals null pointer. There we go. So this cleans out our managers and then cleans up the window and renderer all nicely within this one function. Then we have, all we have to do is delete here, and then we can call our quit logic. Are we handling this anywhere? This isn't part of our, so no. Okay, that's good. I think it might have to do with texture manager, to be honest. Okay, so texture manager does not need to clean up renderer. That's handled elsewhere. It is, however, creating textures within the texture cache. Our texture cache reference is a texture name, which has no pointers, into a texture. And so we have an SDL texture. So this doesn't actually do anything itself, does it? It calls load texture, which is going to load things in, which means we do need to call SDL destroy texture. Surely this isn't our problem. We don't need to delete on these. We don't need to be calling SDL destroy texture literally anywhere else in our project. And we are. That's not good. Oh, this is a leftover. This is code we just directly ported in. Let's comment that out. We'll come back to that later. This shouldn't be causing any issues. Destroy the texture. Menu background.png, menu button texture.png. It should loop through, creating our textures. Get texture. The problem is we're freeing it up a second time, and the only thing we've changed since we last ran this was to link Game Manager to something. Let me see, Game Manager.h. Okay. You are housing a reference to Texture Manager, but you're not cleaning it up. You don't need to do that. Game Manager actually has no cleanup logic at all, which might be a problem. We are referencing that unordered map of game state to vector of entity. I'm willing to bet if we remove this, no, we don't need to remove that. What we need to remove is this. If we remove that, I bet our error goes away. I think it's with an entity. Use of an undeclared identifier game state. All right, we don't need those anymore. It has to be our entity. All right, it's taking in a texture, a source, and a position. Source position is I mean, our game manager does no cleanup logic. So it creates an entry within here that is, let me just comment this out. And then we'll hop over to Screen Manager and we'll change this to fetch. Game Manager needs a return function that will give us. We no longer care about current state, to be honest. What we care about is the standard vector. const. Dot at, I believe. Yeah. Okay, so what we saw here, and this is a weird thing about C++. Well, it's weird to me. Um, if you use the bracket syntax and there is no value at this name, C++ will create it calling the default constructor. If you use at, it returns the actual value. So when you're calling const, which we don't want to modify anything, you can't use the bracket structure because it's technically modifying this, and we don't want any modification going on here. All right. This should get us the entities for our current state. I don't like the name for this, but I mean it's very descriptive, so we'll roll with it. We're just gonna leave this in the header file for now. This should just be able to call game manager entities for current state. We are going to for entity over that render entity. Render, it takes in renderer. We have renderer. This is a pointer reference. Yep. The object has type qualifiers. Has an error I've never seen before. Object type is const entity. This doesn't trigger any updates though, so we should be able to just const it. There we go. This should render to the screen our background. Background's getting rendered. Now let's close and see if the, okay, that error went away. That's good. Progress is being made. Let's close these out. Let's open up our game manager. Let's now try to render a second object on top of that. Exception has occurred. Interesting. Nothing should be calling delete position. I mean, this is the only position in our entire code base that should be calling this. So the fact that this is getting run before we're closing out concerns me. So let's breakpoint on it. Yeah, we're calling entity destructuring is being called here. It shouldn't be. New, we are creating an entity. to store into our game manager, but no cleanup logic should be getting handled in here. What if we change this to be pointer references? We will need to do cleanup in here, of course, but let's pop into the header. Let's modify our entities to be pointers. Nope. Oh, right. We need this. That's all good. Here, this is now a new vector. No, no, it's not. This logic's still the same. It's each of these are now new entities, though. And then we need a destructure that's going to loop through, grabbing all of our entities. I don't know why we're gathering up state here, but sure. Entities, and we are going to then loop through all entities, deleting each entity. And then in our screen manager, we need to alter screen manager. Game manager, get entities, entity. This is now a pointer reference, pointer reference. There. Tilde, tilde, game manager. There we go. We now have a button being rendered onto the screen. So we've got to start. Let's open up the main file. How do we want to? There's a way to get this information. We would have to pass in the game state object. You okay, buddy? All right. If we pass the game state object, we can create pointer references to all of these, which we can, of course, still handle all the deconstructuring or destructuring. But all of these would then require this game state object. It would make Screen Manager significantly less complex, to be honest, if we just pass in game state. I don't really see a downside to that approach. So let's do that. We're going to create a new file called, I don't want to call it game state. Don't really want to call it window manager either. It's technically it's a global state. just call it state.h for now. You need to pull in, include state.h. We're just going to take this whole object as is, pop you in there. You are now renamed to state instead of game state. You are going to need to include game manager, screen manager, and texture manager to make those problems go away. Screen manager calls render frame, game manager calls handle event. You can just call state. We should be able to now pass our game state by reference into all of these. So we can just go to texture manager and you take in, instead of renderer, you take in texture manager. All right, there we go. You take in our include state.h, and instead of, nope, where's our constructor at? So here, you take in state. Does this even do anything in the texture manager? I think it does. Yeah, it has the logic for it. So this is now state. We now store state here. Which fixes that problem, but introduces render. This becomes an issue, and when you call state render. All right, that fixes all of those references. Next up, we have our game manager, which we need to go to the header to start things off with. You now include our state.h. You no longer need to store individual. So you no longer need to store this. It's now state equals null pointer. And then in here, state. Nope, you no longer set that. Nothing else should need to change in there. We then look into the game manager.cpp. So this is now state. This is now pointer reference to texture manager. Pointer. There we go. So game manager is updated. This can now take in our game state. And now we need to update screen manager, which starts with, oh, this one needs to be turned into a CPP file. Oh, it is. It's just not really being used. This one's gonna need a little bit of reworking. So these now all go away, and we now have state star state equals null pointer. This gets collapsed down into that. Of course, it's not gonna state star state, and then this gets collapsed down to state. We need to migrate this logic out of this function and move it into here. Screen manager, render frame. So let's drop it in here. Screen manager. Update our header file to get rid of this. And we get rid of this because it's now in our CPP file. Save all that. Game manager is now state arrow game manager. We now have state renderer. State renderer. There we go. There, that cleans things up a little bit. All right. This now takes game state. Screen manager takes in a game state. Include state. With this, we get one added benefit in that we can now add window, is it SDL position? Nope, it's just position. There's an XY coordinate system, and that's kind of, I don't need it to be a tuple. We're just gonna call it struct window. I like dimensions. There we go. Gets initialized to our default values. We can then get rid of 800 by 600 from here. We have these in here, which are, uh, yep, yep. Game, state, windows, width, and height. Should be width and height, yep, okay. Looking good. So now we have a global reference to our width and height for the virtual sized width and height, which means we can make our calculations that then get rendered out for us. And this will allow us to do things like centering. So if we then go to our game manager where we're creating our entities, we can now create a entity here that takes in, so these are based on the texture's width and height. And we want it, or well, this is the rendered out. So this is the original width and height. But we are taking in, if we want this to be, eventually we want new game, settings, quit. So we have three menus. we do X then Y. X then Y. So X is our horizontal. So this is just going to be um, state window dimensions width divide 2 minus 64. Half this. This is an int. That's a float. So we want to float cast the division here, then subtract our float from double to float. All right. Float, not double. All right. So this is giving us the horizontal centering. We have 3 of these. New game, settings, quit. So we want to perform essentially this. But it's going to be using height. We are going to divide this into we want this horizontally centered with a padding between each of these, which means technically we're finding the okay, so float center x minus 64.0 float. So all of these are going to get a center x. Then we need a float center y. This will dead center the button, which is not what we want long term, but for now it will work. Center y. And then float. We will need a button spacing eventually. I don't want to deal with that now though, so we'll use our. I'm tempted to say the way we want to handle this is actually float. Nope, 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 nope. SDL React F React button sizing. And then we can go through and set each of these. Our buttons are 128 and 32. And then we can create a new pointer to this reference. All right. Screen manager is complaining about state. Is this because we're calling it? these should all be public. State is being imported, which defines state. Let's just call it game state everywhere. We're now going to rename this to game state. This to game state. This to game state. I'm worried about this being a cyclical reference, but C++ should be able to handle that. Oh, there's one more file that I need to do this in for sure. Main.cpp. Oh, I may need to go through and do these files as well. Game state. Come back to that one. Did I miss this? Game state. Game state. Ooh. For conflicting. We'll call this the game screen. I don't like screen. Technically, we would call this a scene. So let's call it a scene. Get current scene. And then we're going to call you current scene. Scene. You need to be updated to game scene. Oh, scene name. Give me just one moment. Sorry about that. I had to see my partner off. All right. So game manager, scene name. This all works. We now have this. The reference is fixed. Let's see what we missed. Texture manager.cpp is most likely the culprit here. This is no longer, no, this is still a game state. All right. Unknown type error, game state. I think this is a cyclical dependency problem because we're importing these here so that we can store them so that they can then reference back to other things. I think that might be why we are having issues. I was hoping that the C compiler would be able to handle that. It seems like it can't, though. That is a bit of a problem. So let me think on this for a second. I'm going to go to the bathroom real quick. I don't know if we can do this in C, but I think I have an idea that'll work here. So if we change this to not have references to these, this becomes a problem. But nothing is preventing us from, right? I don't know if we can do auto here. We cannot. Can we get an unallocated pointer? I don't think we can in C, which means we can't use unknown references to, or sorry, a reference to a pointer to an unknown type and then cast it out later. I guess nothing is forcing us to do it this way. We could just have this, which is the most common thing we need to pass around anyways, in which case we just block that out. The event handlers will move out of here. This just allows us to easily pass around our window and renderer. And then within, we do need texture manager everywhere though. So in this one, we still need texture manager. So we would need to pass a texture manager pointer. Which would be within our header file. We now need to store game state and texture manager. This is now directly referencing texture manager. This should function again. Main now needs a texture manager, a game manager, and a screen manager. These are now all populated like so. We then have to pass texture manager into the game manager. And then we need to do game manager and screen manager down here. And then we need to delete for our cleanup. So our main file is updated. The next manager after that is texture manager. Do we need to make... I think texture manager is fine. Let's just double check the header file. We don't see any errors here. Screen manager, I think this requires state, yeah. So the renderer is still being referenced in here. Game manager, state. Ooh, game manager. This is now scene name. And get current scene and scene name. And this is now a reference directly to game manager, which is no longer defined. So, and this is a reference to game manager as well. We want to call this get entities for current scene. Game manager needs to be defined, so we pass in game manager as a pointer, game manager, do the assignment. We then go to our header file and add game manager as a pointer to game manager. We need to then store game manager starting as null pointer. This should now be fixed. See if we got everything. Screen manager. Oh, right. Main. This now takes in our game manager as well. Cyclical dependencies are gone. We have a button centered. All right. Next up, we want to handle within our game manager. Let's introduce game manager. Let's introduce the remainder of our buttons. So we need to take this button. This one is centered, which means we need the next button iteration should be, so if this is our centered button, duplicate that. We now have one button above. The intention is one button above, one button below. Which would be X. Let's set a variable up here for float of button spacing. So it is going to be offset by float button height and float button width. So we can set these here. And then our button spacing is going to be plus button height divide 2. I don't need that. It's order of operations and proceed enough there. Okay, so now we should be able to do minus button spacing, which should offset it the way we want. And then here we should be able to replace this with button sizing plus button spacing. We now have 3 vertical buttons, so we can do our new game, settings, and quit. And in theory, yeah, we've got letterboxing going on, but it did scale up, which is what we wanted. Let's change our, for testing purposes, and also because I just want it to be different. Let's go into the, we call it game state. Let's do Was it 1020? No, 1080 by 720. I'm going to tweak these numbers a little bit, but this should give us a different layout. Things are still centered. That looks good to me. This doesn't feel like it's scaling right, to be honest. I feel like we're losing our aspect ratio. Let's do 360. This is going to get much wider. It should be easy to determine whether or not our aspect ratio is being maintained this way. Okay, it is maintaining our aspect ratio, which is good. Okay, so let's do best resolution for pixel art games. It's recommending a 640 by 360, which on our computer would come out to be, or on my computer would come out to be this. Then once full screened, you would get this. Okay, so that should be resolved. We now have dynamic, the ability to dynamically position things. Next up, we want to extend our entity object. So we're not just drawing blank squares, is kind of the next goal here. We want to inject text into them. In order for us to inject text into them, we need to utilize our new text entity object. Text entities are going to derive much of their functionality and logic directly from entity. So they will take in a texture. Yeah, I think they just take in everything a texture does. So we'll grab all this and pop it in there. They additionally take in our text to display, which is a string, and they take in the font to use for display, which is our font. They perform assignment to get everything into the position we need, and then this does not need to be deconstructed here because we don't plan on creating it here. We're just passing it in. It will be deleted wherever it's handled from, which we have logic for that already. So we're just passing in the font reference, which should work fine. Our render function needs to do this still, but we need to additionally provide so this is the, if we're using texture maps, this allows us to map to a portion of it. This tells us where to render onto the screen. So we need a SDL3 pointer to text position. So we're going to get text, a font, and a SDL frect text position. Boom. This now tells us where to render our text. And so we can call, why are you using 6 spaces? We can call render the main texture. So entity render return false. Okay, so if this fails, we exit out. We're fine with that. Otherwise, we continue on. We want to render the text. So we have font and our text is not empty and we have a text position. Then we're going to set the color. We need to define color. Let's set a SDL color. We're going to default our color to white. We'll come back and handle defaults for colors later. Let's remove that. Surface, texture surface. We should be able to get that from TTF. This is not a real function. AI hallucinating functions once again. We do have a screen manager that does screen manager.cpp that has a function we pasted into render text. Here we go. So we get our color, we get our surface, render text blended. It takes in font, our C string. We need the text.size reference. It takes in our color, so the rest of this is fine, it looks like, which gives us a surface. We then, if it failed to generate the surface, we want to exit out. We then have a texture. We are creating from our surface. So texture, create texture from surface, create texture from surface, render a surface. Okay, good there. Destroy the surface. It's called destroy, not free. Destroy. Just check something real quick. There. So it destroys the surface. If we don't have a texture, then we fail out. And then we have our destination, which is our text position here. I don't know why we're doing it this way. We should just be able to call text position. Our result is then being passed along, and we destroy texture after we're done with it. This is how we render text. Well, this is how we render text. So this should render out our background and then overlay on top of that our text. We are I I need to read through this for a second because I think we are missing something. In particular, so this creates a texture. From our texture, we then create a surface. That's backwards. Creates a surface. From our surface, we create a texture. So we now have a texture. The texture's position is what's being controlled here. And so this first one will determine where within our texture we are grabbing. We want the whole thing, so we pass null. I believe we can pass null like so for consistency. And then this tells us where on the screen to render it. problem here, this, nothing in here is binding our text position to our container, our entity position. Which means that when we render this to the screen, the text can be outside of the button or the entity, which is a bit of a problem. I'm tempted to say we add a little bit of logic into our function here. And instead of taking a position, we take in offset. If we take it in as a full frect reference like this and then mutate it, we can use this as a relative text position. Here we would want it to be a full position, but when it's passed in, we want it to be assume text position is relative and needs offset by position. So if we are provided both of them, then we update the x to be plus equals x and y to be plus equals y. We additionally want to set text positions w. Okay. We want it to be if text position w plus text position x is greater than position w, then we want to set text position w equal to position w minus x. Okay, so this will say, let me delete that line, if our width plus our offset is going to put us outside of the bounds of our container, then we want to update the width to be restricted within the bounds. There we go. This should allow us to do a relative text position within the container without overflowing the container, but still allows us to provide max width on our text and such. That should, okay. We need to provide font as part of this, and I don't like that. Can we not? So if we remove that from there, remove it from here, and remove it from here, we can pass renderer and font here, and we no longer need to store font. The downside to this is we use one global font, technically. But we could, in theory, reuse elements painted onto the screen with different fonts by just providing a different font we call render. We just need to know. All right, so we now need to go to our game manager, .cpp. Let's pop into our header so that we can include our text entity. We can now change, these are buttons, so let's change these buttons to be text entity, which is going to require us to include additional parameters. These additional parameters are, so it's texture, source, position. We now need the text and the text position. So we're going to create the SDL3 button text position, which is going to have we literally just need this as offset for X, offset for Y, the width, which is going to be our full button size minus 2 times our offset, and then the height is going to be the full button size minus 2 times our offset. We can pass this in as text, which is a new game, and a new there, and then boom. I'll come to back to that here in a second and figure out what it's complaining about. Settings, fix our there, and then here we've got, let's call it quit instead of exit. There we go. What are you complaining about? Expected a closing bracket. Why are you expecting a closing bracket? Comma, comma, comma. That's looking good. This is looking good. Can we not do... So we got texture manager, null, rectangle, X, Y, width, height. Oh, where'd you come from? There we go. There. Now, assuming everything worked correctly, we should have text. We're not going to have text. I'm not providing font. So we need to go into the screen manager, our CPP file for it, and within our render. Okay, so we need to now determine how do we do types of? Actually, it wouldn't hurt anything to just overload this to additionally tank font, to be honest. If I change this to auto, font, we do store font here, right? Yeah. This is saying it's always entity. So um, C++, check if base class or inherited. I'm looking into derived functions, derived checks to be exact. This is super weird. This is how checking is handled for it. So assuming that it, of course, assuming it works. Um, you define a virtual. A virtual is required. Then you can define your classes that are inheriting. So you set up your inheritance. Then you can do a dynamic cast and check if a derived pointer is a dynamic cast. It will fail if it cannot derive it. So I could do a check like this. All right, well, let's give it a try. Let's see if it works. So we'd go into entity, and the first thing we need to do is create a, I want to know. Well, I want to just try it without a virtual. Let's find out. So we have entity, and then we have a text entity, which inherits. That's all good. So we should, given a pointer, screen manager is taking in here. It is pointers. So if, what is this derived? Oh, if this would be text entity equals dynamic cast of text entity star for entity. We need to figure out why that's erroring. Given an entity, do that. Else. Const or other type qualifiers. Can't call it const. In order for it to be considered polymorphic, I think that's where virtual comes in. So if we go to entity and set up, I think this is bad for us. I'm worried. C++, what does class virtual do? It ensures the correct function implementation is called based on the actual object's type at runtime rather than the pointers or references type at compile time. Oh, if that's what it does, then what we actually want is this to be virtual. This is our function that's being overwritten, so that's what we want to be virtual. That should do it for us. Great. I was not expecting this to function at all. Let's jump back to those errors, maybe. Where'd our terminal go? Pointer is null. Called C++ object pointer is null for entity render, state render. If not state renderer or not font return. Can't render in those cases. Da, da, da. We'll just call you scene. Okay. I'm not sure why it's telling me that it jumps to main menu when that's kind of what we want to do. Calling. Why are you telling me all this? I think this is tied back to that pointer. D pointer is null. Okay. So if I this is what I want. Text. It's going to attempt to cast this, and then we're checking to see if this is equal to null pointer, right? Let's make it explicit instead. A value of type mode, right? I don't think we need this anymore. I mean, this is What if I do this, and then instead of using that here, we can still call entity, but we do a text entity. So this is checking to see if it, oh, right, not equal. So if it's able to cast it through our dynamic cast check, if this is possible, then we cast it. The problem is this is casting it twice, and this is something that runs constantly. This is our render loop. Casts are not computationally heavy. Doesn't mean I want to run them constantly, though. Hmm. Let's see if it'll work first. We need to fix our formatting. We're having a rotational issue as well. I think my subtractions are backwards. The pop here. No, assuming pointer value is null. These are all warnings. I hate that it's printing this out. Because we're using this as virtual, can I just inline virtual entity renderer? Okay, if I go to text entity, do I need to make this virtual as well? No, that's not gonna work. It works, it just throws a bunch of complaints about it. What if I just do this? I don't know what happens. Seg faulted. No complaints though. Alright, so we cannot do dynamic cast, or we cannot do strict casting. This isn't helping our case. If we're stuck with the warnings anyways, we might as well use the option to use casting twice. Alright, let's figure out what's going on with our text formatting. Position should be X, Y, button size. All right, so that's part of it. If we want to is there a way that we can SDL3 render text centered? It is going to be a bit of a nightmare. You need to take an the text, taking the font, and then call a function called measure text, which will modify a pass by reference int for width and height and return it back. That is not how we want to handle this. Let's tweak some numbers. Okay, so x inset. We want this to be inset by 16 on W, which should be the button width. So we're going to say button width. And button sizing. No, that should be button height. This should be button width. Right? Is it width height or height width? Oh, it is width height. Okay. So we need to do x width minus x times 2. Y height minus y times 2. This one's going to be a bit of a problem because, no, that's actually fine. Makes me think our logic inside of text entity is incorrect. So let's just we got x y w h. Boom. It's gonna be spamming this, so we're gonna have to kill the renderer pretty quick. I only called it once. Interesting. Having negatives here is our problem. That's why we're getting it rendered right to left, bottom to top, instead of left to right, top to bottom. Okay, so text position is going to be x plus equals. So this is coming out correct. Text position W plus that needs to be if it's greater than. Oh, nope, I see what's going on. This is our offset. Or sorry, this is our width. This is our offset. I was correcting it to screen position before we were correcting our height and width, or capping it. So that should do it. All right. Solves that problem. But since we're not getting width, oh, I want to introduce a way for us to handle centering. The problem is that we need, in order for centering and text aligning to work. Okay, let's do it this way. First off, let's get rid of this. We should be able to provide. Null for those two values. I want to see what happens when we do that. My hope is that it does not skew or scale and just left aligns. That's not good. It didn't hit a runtime issue, which is good. Are we doing... It might be tied to this computation we're running here. No. We have to provide a size to get it to render out text correctly is the problem we're running into. But the width and height, as well as our offset to accommodate it, changes based on the text itself. So it gives us two options. We can continue down this path and try and get dynamic text rendering where we can pass in like left align, right align, center align, and a box area so that we can dynamically set these kinds of things. Or, which I think we're going to need regardless, we need a way to provide. I wonder if we set just null here. We need a way to, because we're going to have dynamically rendered text eventually. So we need a way to dump out text to the screen that's not going to cause weird rendering side effects. Because right now, this is what we have. So different lengths of text is going to cause it to skew in different ways. SDL3 prevent text stretching. Let's see if there's something we can do about that. By using SDL render logical presentation, never stretch. Your fonts and pixel art will scale cleanly. You can query the actual presentation rectangle with this if you need to draw a UI element relative to the actual web visible area. Optional. So I want to see if this is a flag we can actually set, or is AI hallucinating? My money's on AI hallucinating, but this should be a flag that we set here. Didn't think so. Let's try integer scaling. This shouldn't change the problem we're seeing, by the way. It should just fix a different issue that we're probably going to run into down the road. Yeah, see, still stretching. But I expected this to further scale up. SDL3 examples. Let's see if they've got a text-based example anywhere that we can rely on. Debug text. I wonder if we have render text and the like. If we go to our render function for text entity, destroy texture, destroy surface, render texture. Is there an SDL render text? When we're loading in string, I just need to look at these, I think. Specifically, SDL, TTF examples. Get render output size, set render scale, get texture size. This is how you center and scale. That's a bit of a nightmare. Well, let's translate it over. Text entity. We are going to assume, until we have reason to believe otherwise, we are going to assume that we are always centering. So we have text to render. And then, so that's establishing everything. This is drawing everything. So this is the logic required to center, render, and draw our text. That is simpler than this, but I'm also noticing we can't set font in here. Let's see if you can assign font. It looks like they are globally applying it in the init stage on their example. Oh, nope, here it is. Before all of this also happens. Oof. So that's the entirety of their example. So we're doing the texture from surface, destroy surface. We're doing that down there. This is their scaling logic. Here's where they're rendering the texture. Here's where we're rendering the texture. They're using destination instead of text position. We don't need to handle those two. Okay, we don't need to set the draw color. I'm assuming we handle this in our, yep. Okay, so this is the center logic. All right, so we're getting the width and height, or sorry, we're initializing variables for width and height. We're initializing a variable for the destination. We're setting a scale. We'll come back to that in a moment. Actually, no, let's just remove our scaling. We might need it. Remove our scaling for now. Remove our scaling. X equals W divided by scale minus W. This is the new scaled width. We shouldn't need this if we're not scaling. I'm willing to bet this is going to draw in the top left corner. Let's find out. Yep. Okay. If we assign this like so, if I understand this logic correctly, it should now render within our squares. Okay. It's not scaling because we need to adjust our scaling. So let's bring this back in. We just don't want it to actually scale. This is just going to be centering it. Ooh, it's centering it within the entire screen. So if we take this back out, they are now positioned correctly. But our problem is that we're assigning these without updating what they should be. Because this is getting our output size. So we need to set destination.w equal to w and destination.h equal to h. This should update how we're rendering based on what it wants to be. Oh. W divides scale minus W. Let's just see. I just want to see what this is so I can look at it. I'm pretty sure this is allocating everything into the center of the middle one, but it is sizing them correctly if I'm not mistaken. The worst culprit for this is our quit. So if we comment out those and run it, yeah, it's still doing. It is fitting it better, but it's still stretching, it looks like. Because if we bring in this one, comment out this one, it should from the looks of it also, yeah, it's also fitting to the container. It is fitting to the container now, which is an improvement. This is the size of the screen. For the output size of the current rendering target with logical size. This isn't giving us. Let's try this. I forgot to uncomment that when I was adding the scale stuff back in. So let's. What if I just do this? Okay. If I'm not mistaken, then hopping over here, commenting out our new game case and bringing back our quit case should have text that is not stretched. It's still getting stretched. What if we don't? What if we just do that? And then let's duplicate these lines, bring them in, and then we'll just set these. I want to test something else, but we'll just set these to uh, X and Y. It's still causing quite a bit of stretching. Let's not modify our. Are we providing text position in here anywhere? No. Let's not adjust this. No, we still want to adjust this. Let's not adjust this. But then let's bring these back in. To get a more holistic view. New game looks good. Settings looks good, to be honest. It's the quit problem that we're having trouble with. I would expect this to be much shorter. I don't know why it's forcibly scaling up when we're not giving it a size. Like, width and height are starting at 0. We're not assigning them anywhere. We're not using scale any longer. So we can remove all those. We're taking in the texture, which is just coming in from the texture surface, which is getting just font and text. So render text blended. Other TTF underscore render text. I don't know what wrapped is. Let's find out though. Does it return a surface? Yes. Okay. So we get a surface. We get a texture from said surface utilizing the renderer. We destroy the surface to clean things up. We now have a texture. We destroy the texture down here. We render the texture. We are giving it, we're telling it to use the entire texture and spread it across the entire destination area. Destinations W and H are being set by the texture. Ooh. Texture. There, I think that's our problem. Let's try that. Hey, I got rid of our scaling problem. Boom. Okay, so we want our We don't care about output size. We want to set our render scale. And then assign our, okay, and then scale, okay. We want to assign the width and height. Actually, we don't want to update our X and Y. Our X and Y are correct. Honestly, do we even want to modify this? Render the texture. Right. So this is setting our top left corner. We need to then adjust this top left corner based on our scale size. So we need to fit our, we need to change our scale. Okay, this is not a const. So instead of setting scale here, we actually don't want to set scale at all. Actually, we might want to set scale. I'll comment it out so we have a reference to it. This is telling us what our texture wants to be. And this is where our X and Y, this is our top left corner. And this is the size the texture wants to be. Now we need to know the ratio between the, we're going to call this H scale, so height scale and width scale. Our height scaling is going to be set based on the differential between the input height and the like preferred height. As a float, we don't need to float cast that because all of these are floats, right? You use floats for everything, yeah. Text entity. And then our W height. W scale is that. And then we set scale to the smaller of the two. We don't need this any longer. Include algorithm, I believe. And then we can just do min. Yeah. So we get the smaller of the two. We now have a scale. Our X and Y, no, our destination gets its, we still need to do these. Our destination gets its W and H scaled now. We will come back to this to center it, but this should scale it to fit. It's going to be left aligned within our container though, until we handle the commented outlines in the center. We now have adjusted text size. Okay, so our next step is we've now scaled our height and width numbers. We need to make a couple changes to how we're bringing this information in. All right. We want to pass in XY offset. We don't care about height and width, technically. And so if we are providing a text position, we're giving it relative, and this is now, we'll call you offset. Do we have an SDL offset? Is that a no? Position? Maybe a chord? C++. Position type. We want include utility, and we want to pass in a std pair float. Okay, and then we're going to call you offset. We're going to call you standard pair. And we're going to call you offset. Come on, you can do it. Offset. There we go. And so we no longer have to update here, because we have to do a bunch of math in our centering down here. Which means if no offset is provided, let's go ahead and default value that to 0, just to be safe. And so as long as we have a font and text, we can now create x equal to entities, I believe we could just call it position plus offset first, offset second. So this gives us the x and y inset from the top left corner of our container. I was looking at that Arusus, the SDL point. I don't know if there's a benefit for doing it as a point though. This would technically be more accurate in that we're providing a horizontal and then a vertical offset. Also, welcome, Stephen. Sorry about delays on chat. I'm using Restream so that I can dual stream between YouTube and Twitch, and it seems to be having some issues. So I'm not sure if I'm getting, I'm not sure what kinds of delays I'm getting on the tech side of it, but I can say that my video renderer is something like 8 or 9 minutes behind. I have to keep refreshing it, which resets the chat. So getting access to this on Restream has been a bit of a nightmare. I'm not sure what's going on there. So if I miss messages, I am terribly sorry. I can at least pull them up on Twitch. Okay, yeah, Roostus, that's what I was thinking as well. I think it makes a little more contextual sense, so I'm not too worried about it. But this should be getting us now to the point where we have our insets correct. So we can offset the text position. We then need to, let's assume we use these for both top left and bottom right, so we're always trying to shrink and expand based on the container size consistently. There's nothing preventing us from providing a non-existent background texture inside of renderer, or sorry, inside of the render function for entity. So if we, if not, nope, kind of like that from a logical standpoint. And the reason for that being is it allows us to continue operating in the case where we don't have a texture, which is important because um, this would allow us to reuse text entities both with and without containers. So we still need the bounding area, and we would center and offset within the bounding area, which means we can always center. And then in the case where we don't want a container with borders and stuff like that, we can just provide no texture. So this can just be a null pointer. And it won't attempt to render anything. We should probably do if texture is equal to null pointer, just to be safe. So if we're not given a texture, then it just blindly passes through. It doesn't actually render anything, which will allow us to continue on. And then this text is always being positioned based on the screen anyways. So we don't need to worry about, like, it's not actually relative to its container. That's why we're doing all of the computational logic here to make it relative. Yeah, so this would allow us to render text visibly inside of a container with a background texture, offset, always centered, as well as we can just provide zeros for our offset, which by the way is our default. So we can just exclude offset. So we can just run a constructor with just this portion here where texture is a null pointer. And we'd render text on the screen without a container and without an offset, which allows us to always center. I like that. All right, so we do need to calculate our new update for how we're going to handle offset now. So this gives us the updated X and Y position for our destination object. We then can create a texture. This is the size it wants to be given a perfect world, but we refuse to hand it a perfect world. So we then take the horizontal scale, creation being the difference between position, which is coming in as the texture's position. So this is where we want the main outlying texture to render. So this is the full area given for us. We then divide by the area we want to be to see what kind of scale we're in. We need to, This can't be the full area. We need to subtract offset dot first, horizontal first, yeah, okay, times 2. It should be horizontal then vertical. Offset dot second times 2. So first should be horizontal, so along the x, and then second should be the vertical along our y. And so this will get this will take the total space, reduce it by the offset amount times 2, so it's equally offset on both sides. Then we divide that by what it wants to be, and this will be our new scale. We repeat that for that. We take the lesser of the 2. We now have our scale value. We then adjust the width and height by scale. We make no adjustments to x and y, and it should get us fairly close to centered now. It's going to be off just slightly, though. Oh, right. We need to update. Okay, so we now need to provide button text positions. This is now just providing these two. So let's remove all that, provide that, then this becomes that. In order to make that work, we need to go back here and grab that. Jump into the header. Oops. Cancel. We now have button text offset. We can pass this in here. That should fix that. We're going to have to clean this up at some point. This can get too much. That's not what I was expecting. First off, let's just dump something out real quick. Alright, we're not short-circuiting it. Let's take its recommendation. It shouldn't be backwards, but let's see if it's correct here. X offset first, Y offset second. Our width oh right, I have these backwards. Width and height. Hey, there we go. Okay. It is left aligned, but it is getting the padding injected correctly around it. So now we just need to fix the left or top position based on which scale we ended up on. We don't need to handle it that way though. What we can do instead, we can set our X position to position it'd be X position plus our width minus width divided to, yes, this. Our Y position should be nearly identical. Be Y position height minus destination height. Yep, that. Okay, this should center it. There we go. We now have our menu rendering out correctly. Okay, this will dynamically center and handle all of our text cases. So we can now create text-based entities to render text-based content in our global format. Sorry, in our global font, because we're not having to reference font. Oh, we are sitting here. So we are always passing this in, but we're injecting it elsewhere. So it is technically global at this point. It's just has to be passed down every time. So we can now render text-based entities with optional backgrounds. And just to make sure that we can in fact use optional backgrounds, I want to set you get null pointer. Should still render out quit centered in the same spot, just no background. Yay! So we can do with and without textures, with and without offsets. And so it should still center here if we just remove that. It's just going to be bigger. Yeah. We have no offset, so it's just going to full size it. This is a whole bunch of duplicated code that we can condense down. We need to handle some sort of identifier for these if we wanted to condense it down, and a handler. I kind of want to move this out of our manager. Otherwise, we're just going to have an absurd, like, there's going to be so many lines in this file just creating all of these. Let me think about it for a second. I'm going to go to the bathroom real quick and grab something to drink. So I will be right back. Take a moment to stretch, please. Okay, we're back. I'm programmatically creating these. I could dramatically downsize this if I were to remove the context from them, and then I could store it into a entity structure. So I could, in theory, it requires some duplication of things. And I'm dynamically calculating these though. Technically, we're centering these, is what that calculation is for. If we provide a if I were to provide a centering flag, you want to come here too? Oh, no? Okay, just eggs then. Alright, pick a spot, lay down. There you go. Edgar decided he wanted to come over here and lay on my lap while we're working. The little kitten got jealous and came over here and scratched at my leg and then got stuck claws in my pant leg. So I had to help her. I don't like how much bloat this is adding to a otherwise fairly concise class, because this is all creation stuff. Which, in a perfect world, we would eventually abstract out into like this. This is our. It's not quite like assets, but this would be all of our like data elements. You know what I mean? Right now, it's just creating the sprites and textures for the menu, but eventually this will be all of our cards, the position of any characters on the screens, everything would end up in here. Which is why I don't want it to be handled in like this. These are all the objects within our scene, is what this is. I guess I could create something akin to a scene manager, which just provides the scene name and entity creation. It's just, I could provide that, instantiate it, reference it, and it's just this. Which will just help keep the game manager on how we do all the interactions with all of the, because these are all the entities within our scene. Which for us, we're just categorizing everything as an entity, including backgrounds. So this is going to get pretty damn bloated. So being able to remove this from our game manager logic and have an entire structure that is all that's in there is creation of entities allocated to our given scene would probably be pretty damn useful. Yeah, let's do that. Okay, Eggs, you gotta move. I can't type with you in my lap. Come on, big boy. Oh. For those of you that haven't seen Edgar yet, this is Edgar. Fucking pick him up. This is Edgar. He's a 20-pound, all black cat. Looks like a small panther. Are you upset yet? Are you gonna hop down? Can you go, please? Oh, right in front of my monitor. Okay, there we go. Okay. So let's relocate all of this information. We can generate. Yeah, we're just going to create a new file. Sure, we'll just call it a scene manager. Okay, we now need to grab all of our constructor information out of here. We need to create a new file, scene manager.cpp. You will include let's do all of that for now. Pragma once, and we're going to include our SDL reference. We need to migrate So that gives us that. We can then grab these. Dump them in like so. Get rid of you. I shouldn't need to clean anything up for this one. Oops. Can I get away with that? Nope. No, I can't. Okay. We're gonna have to handle porting those in here in a moment. we shouldn't need that. I feel like the game manager itself can instantiate the scene manager. This is no longer relevant to us. Oh, nope, this is scene manager. Where's game manager? That was it. Game manager.h. This is no longer needed. You can now import include scene manager so that we can use scene. There we go. Okay, so game state needs to go at top. Scene manager can reference it as scene manager equal null pointer. Let's reference you as a pointer. You will then instantiate. Nope, nope. I don't want you to do that at all. Scene manager equals a new scene manager. You're going to provide it the state. Shouldn't need texture. Scene manager. Let's work backwards from that. What do you need? Let's get rid of some of the. All right, scene manager. You are going to need state, so we do need that. So if we hop over here, then we can get this from here. This is going to need to be provided, which means we head over here. Game state. We are going to need to include game state. Solves that. It gives us state. We need to include our utility. We're going to need to, we no longer need this. We now have scene incorporated directly into it. We need to start tracking game entities within here, which means game entities. This all goes into our scene manager. Which means we need to move includes for vector, ordered map, and string all need to go into here. Which should give us that. We need to include entity, which gives us that. If we go over here, okay, progress. We need texture manager and text entity. Okay, so we can get include text entity, easy enough. Include texture manager. We then need to take in our texture manager, which means we need to take in texture manager and apply state. texture manager. There we go. We do need to make sure this is getting stored. Like so. No more errors in this file. It covers all of our cases. We might need to change this. So that's looking good. This is looking good. We no longer need, I don't think we need any of those. Game entities is now managed by our scene manager, which needs to take in texture manager, state texture manager. So this can be instantiated. We now need to add a delete for scene manager. And just to be safe, scene manager is a null pointer now. We no longer need to handle this logic. It goes into the scene manager. So we do need our deconstructor here. Let's add deconstructor here. In a perfect world, those are the same exact thing. What I just deleted and pasted in, but one I know I can trust, the other not so much. Alright, we still need to handle this, but that is going to become a public function on here, so we can change scene. We can get the current scene. We can also get entities for the current scene. Let's do that into here. And we'll update it here to not have the body. And then here we need to add that. And then here we no longer need to call this. We do need to call this. This is a pass through to scene manager dot right arrow function because it's a pointer. Get entities for current scene. Okay, current scene. So this no longer manages anything to deal with the scene. It all just relates it down. This is going to handle all of our transitional event handling logic. This is where all that's going to do, which is why I've been decoupling this. So let's move this into Game Manager, CPP, right here. There we go. And then here I can semicolon. We'll grab this, migrate it over to this file. There it goes, and then we will clear that out. Okay, Scene Manager, you should be defaulting to main menu. These get instantiated, you have entities, boom, boom, boom. Should work. What a miss. Right. Screen Manager also had references to things. You are now calling Scene Manager. Scene. We need to import Scene Manager to make sure we have those definitions. Back to where we were. Perfect. Now, we can add all of our scenes into the scene manager and not have to worry about it. Into the scene manager.cpp. Again, in a perfect world, this would all be codified into data objects so that we can like edit a data file and it would generate it for us. We might go down that path at some point in time, but that is not something I'm concerned about during a game jam. So we're not going to handle that right now, at least. All right. I am going to fiddle around with things real quick to see if I can get this working a little bit better. Okay, there we go. Let's add a small helper function in here to return a text entity pointer for we'll call it create button. Button is going to need, we'll do create menu button. Let's do this as part of scene manager. Scene manager.h. For now, you're just going to grab that, and we are going to put you under, let's do private methods. I like this. Let's do private here. All right, that solves this one. Button sizing can be coded directly in. Or button height, button width, and button spacing can all be coded directly in. And text offset can be coded in. This is all the formatting required to properly size and situate menu button content. It then renders into this, which then chunks into this, And so we just need to provide a is a string. Okay. String text and then text. Oh. Oh, that's because this is part of this, and then this is its own line. All right. This should allow us to just iterate through creating buttons. New game. Settings quit. We just need to update this to take in the string standard string const text. Boom. We need to make sure we are importing string here. All right. All right, we need to fix that. Right, we need to draw offsets for each of them. So if we put this back in, we can do a let's reuse what we did here. Offset. As we iterate through these, we can do would be horizontal then vertical offsets. So we can do this. So it'd be horizontal offset, 0 across the board, vertical offset. We want to do button spacing. I kind of like the idea of indexing it. Let's just do int index. So this one's minus button spacing. So we're going to add this is going to create a separate problem for us, but we'll get back to that in a second. For now, int. And then here we need to go through and remove you guys, update this to that. All right, solves one problem, creates a second problem. We now need to center our entire container based on our indexes. That one's harder. If we provide our account of buttons, then we know how to offset our index. We always want in the case of even, we have to offset by a half. if we know, so we have a static button height, we have static button width. If our button spacing, if we do this as, we'll call it button gap. If we want this to be the distance between buttons, so height, width, gap. This is our text offset, so this is how we're doing the internal. Are we doing this anywhere else? No, we can just do this. All right. Okay, so now we have button sizing. We can use button sizing here when we're creating it. So we can just do new here, and then we can directly pass it in here, which means we can take the math here, and we can call button size. We are going to rename this to button position. We removed this logic. Okay. So now this should be pretty dumbed down. We grab texture. We tell it to take the full source. We tell it to provide destination based on the size we're going to calculate here in a second. Given this text that we're passing in, this is the inset that we're doing, which is static. This is a menu button. Now, given an index for our current button and the total number of buttons, we want to calculate the, we'll assume, because we can, in this function, within this context, that it's always a vertical list of buttons. Our total offset, total height, is going to be the number of buttons times each button's height plus times the button height plus the button gap. So this is going to be, let's say we have 3 buttons, it'd be 1, 2, 3. We do need to subtract 1. So yeah, minus button gap. This is the total height that our buttons are covering. We want to vertically center this within our window. So we are going to take the window height, float, yep, this window height minus total height, divide 2. So this is going to get the topmost spot. We then want to find the current button's position, which is going to be the start position plus index times, yep. So in the case of index 0, so our topmost button, this is 0. So it starts at the top. Index of 1, we shift 1 button height plus the gap below that button down. Rinse and repeat. So this is how we calculate the top point of a given button. Alright, and then we now have the calculation for width because it's always the same because we are just horizontally centering and we are not stacking anything. We now have the button Y, button width, and button height. There we go. That should fix our problem. We need to go here and we need to tell it that we have buttons. And then we need to go here, and we need to tell this that we're taking in int total buttons. There we go. We can now create any number of menu buttons with a single line, and we just need to update our count. This will make adding these a lot easier in the future. We now we need to provide a contextual way to reference these entities so that we can bind actions and selection states to them. My original plan for this does not account for keeping our backgrounds within here. And this is only a problem because we are doing the entirety of all of our entities in a single flat structure. If we were to decouple, if we were to expand this to be a complex structure that allows for multiple scenes to be overlaid across one another, we can store we could store our buttons as a scene, which then stacks on top of our main menu scene. It's like just an element within our main menu. We would need to be able to provide this as a reference to another scene. So that's something we can do, and I don't think this is a thing we can do in C++. If we were to create a second enum in here, that is our, no, that's not what I want. If we were to create a second enum in here, that is our so if a scene's the total structure, then we have, we'll call it a scene component. It can be main menu background is going to be one component, and then we've got main menu buttons as a component. Now, instead of storing it like so, game entities becomes a scene component map. And then we have, do I even need scene manager here though? I didn't think so. And then we have our, we'll call them scenes, which is a map to scene component. This gives us two benefits. We can now create clusters of components that will render onto the screen that we can reference to do things like selection from wherever. So this is how we will handle cycling through our menu buttons. Our selected one is just an index at that point. Super simple, easy to cycle through. We additionally get the benefit of, since we're decoupling these, we can reuse these components of our scenes when we're constructing our scene layouts. So we need a method for get current scene. Which will return our current scene. We need a method for get entities for current scene. Do we care? I don't think we care about the intermediary. I think this is all hidden behind the scenes, and so we can go into here, and instead of just dumping this out, what we can do is we can take in scenes. That's what we called it. No, what do we call this? It's called scenes. Okay, we can go to scenes dot at current scene. So given a scene, give us our vector of scene components. Given a scene component, give us our vector of entities. Here, given a scene, we should be getting back, this is a vector now. We then want to return, we want to iterate over the vector. This feels weird, but for given a scene on scenes, we now have components, and then scenes dot at current scene. This is going to give us back our component, but name for sure. This is our list of components that's coming out of it. So scenes.at current scene. This should give us back this should be vectors of these. And so now we need to either no, this isn't components. This is going to be given scenes, we're returning back the scene. dot at would be this. So it is just literally the scene component. Nope, by name. And so then we can go to game entities.at component. This is our vector of components. We need to merge all of these though. So we have vector entities equals vector standard. We can then entities is plus equals an option with vector? I don't think this is the thing you can do with vectors. AI is just hallucinating an operator. End begin. This might actually be what we want though. We want to insert based on the endpoint in it that as it exists currently, the beginning point here, and then it goes until the endpoint here. All right, this should give us a one-dimensional array of all entities across a two-dimensional scene depth. So we can now combine scenes across our component segments and return them in the same structure we were returning before. So that's one part. And then we go here, and now we need to create correct, and then game entities for scene component main menu background. That's correct. And then main menu buttons. That's correct. Can I reference this within itself? I don't know if it'll let me do that. Yeah, I didn't think so. There we go. We now have two-dimensional scene structures where we can reuse components within a nested approach on how we render out scenes working across everything, which means now we should be able to create component sets for each of our card groups, which will allow us to um, handle our selection easily, but it'll also allow us to reuse our card groups. We should additionally add a field to entity, which can be a boolean for visible. And then when we go to render, if texture equals null, return true, or not visible. So if we run this now, boom. If we then provide a bool vis equal to true, visible equals vis. Do that, and then we can go here and let's set in our create menu button, let's just toggle visible on our entity. Our text entity is going to need to inherit that constructor. Offset bool viz equal to true, toggle viz into there. Go back here. We should be able to toggle our text entities to false. And now our button should disappear, but our background should stay. Okay. We need to handle if not visible, return true. Helps if we handle it in the renderer. I got a better way of handling this. That's what I want. Okay, let's gonna do that, and then we'll go to entity, and in the case of renderer, if there's no texture, we'll say it is actually good, and if not visible, then it returns false. That way it'll cascade down the render cycle. So now we should get the same result without having to explicitly add it to every renderer cascading down. There we go. And then we should be able to head back to our scene manager and just remove that flag. And our buttons are back. Great. Okay. I want to go through next and start adding our event handlers. In order to do that, we are going to need a way to toggle states on elements when they get referenced. We are currently storing them directly as text entities, which doesn't have any sort of selection state associated with it. So we need to extend our text entities to incorporate a ability for selection. I think the next logical step here is to introduce a new entity type that is a selectable entity. That can see, the problem with that is not only do we need to maintain a Boolean saying whether or not they're selected, we need to incorporate it as a state, and then we need to toggle a texture. The intention for that was to always be part of sprite, because that falls under the categorization of animation. And then we're extending that by card to scope animation to have idle and select. But now our buttons need this as well. And so we have text entities, which render out just text, and we have which are enhancements on sprite. Or sorry, we have an entity which diverges into sprite and text entity, and then collapses back into a animated entity. So I'm wondering if maybe we need to take our animation information and hoist it into entity. Because it makes sense when we look at buttons and um, cards to have the ability to toggle between different animation states. And if there's only one, then it's just we can ignore the cycling. It doesn't need to cycle through the animations. It just renders the one static animation. However, background doesn't make sense all of a sudden. Because background right now is just an entity. It is the most basic of basic entities. There's no different context for it. There's no selection states, nothing. If we wanted to do an animated background though, that would be something we could do. The problem with the problem with our text, or sorry, a background inheriting from sprite or the animatable entity. The problem we're going to run into in that situation is that one, not everything is animatable, and now we have this weird segment going into it. And then two, if you look into how we're handling our definition on sprite, it's containing a mapping of type 2 vectors so that we can iterate through on the different states. So when we're in idle, if you have multiple entries, it can cycle through them based on the frame rate. That's how we do animation. And so when moving, when idle, when selected, whatever, it's going to cycle through these based on our frame rate, given that we have multiple frames that we can cycle through. It's not going to try and cycle if current frame equals frame rate. No point. Sorry, if current frame equals max frame. Sorry, current frame equals frame length minus 1 would be the exact number. Because if this is 1 and you're on frame 0, there's nowhere to go. And so we don't want to just spend a whole bunch of time doing calculations that we can avoid. Which is fine for a stable animation, but then we need to say, well, background only has idle, it doesn't have a select. So do we have a new custom type coming in that is background state enum? And so now we have a card class, which extends our sprite, which extends our animatable entity, which extends entity. We're going to have text that doesn't animate. We're going to have backgrounds which don't animate, which means entity and text entity I think needs to have are good the way they are. I think our button just needs to be turned kind of like the card into a animatable version, which means that I think we might just need to do sprite to get an animatable entity on the screen and then merge or then create a button that will merge the animatable portion of the texture with font overlay in the renderer. I think that's what we might do. I'm going to duplicate our card for now, and we're going to rename this to button entity. You get to create a new entity type that is going to include text entity. You are called button entity. You're going to inherit from sprite and text entity. Then create an enum that you will then take in that is button state. Okay, you have button state. We are going to forward this as a public reference that is going to be button state, maybe struct, no, it would be enum button state, button state, right? I believe we can do this, which we now can then pass in through here. And so when we're creating our button entity, we need to take in our, do we want to do these as separate ones? It might make more sense to just bring in the entire idle animation set. Why are you like this? VS Code. There we go. This will take in button state. Can we define you like this? Nope. Must be an integral type. Can I define that? No, I don't remember type. Yeah, I didn't think so. It's going to be hard to provide this as a referential point outside of here, is the problem I'm running into. Can I define it as, if I just take this, drop it in like so. Can I define you as a static? Well, let me just do that. Oh, it will. Nope. Nope. Not static. Is it inline? I thought it was static. Storage class may not be specified as static. That could be a bit of an issue. Although apparently it's letting me do it now, so that works, I guess. Okay, this solves that problem. We now have a way to reference our states that are also being passed to our sprite. If we go to the sprite definition, our animation map is a fully formed animation map, so we need to be able to provide the full structure in one call. With given frame rate, we will default you to 100. 10 frames per second is, maybe we'll do default frame rate of 300 milliseconds. That'd be 3 frames per second, which is going to be slow, but that's fine. I'm not looking for super high graphics, and it's something we can easily change in the future. Okay, I don't want a card right now. Our button entity is now taking in, we need the entire animation structure. So this is going to take in this. And button entity takes in that. But you need to be button state. Okay, so this is our animation map. Let's not take in anything for frame rate. We have to pass in texture source position. So these are all required values that must be passed in. Where's the rest of our text entity? This isn't everything, is it? Button entity, texture, source, position. Texture, source, position. We're not getting like half of these. Where is my button entity? So this will get us our text. We now have our offset coming in and our visibility. I don't want to, we should be able to set these. So we want to be able to provide if we go to entity, we can just make visible public. We can now set this. I don't know if I want to do just straight up public accessors on visibility. Being able to directly modify these is a little concerning for me. Being as it does mean that we run the risk of modifying something we shouldn't, or modifying it in a way we shouldn't be able to. I'm gonna stretch for a second and just try and think on this. So I'll be back. And we're back. I haven't really come to a conclusion to this though. The makes it easy to modify. We don't have to add a lot of setters. We shouldn't have to add getters. It should be fairly self-contained. The main thing I'm thinking about is if we want this to be editable, we would need to provide a void set visible and a void set position. We would need both of these to allow us to update visible and position. We can then remove them from here. At least we can remove visible and just always use the default. Which simplifies the visible should be true here, yeah. This simplifies the logic coming into here. We no longer need this. These two are kind of conflicting in that sprite should be pulling in entity, which means it needs to be bringing in all of the aspects of entity in its constructor as well. And it's currently not. It needs to be pulling in all of these so it can set all of the default values in here. That way it constructs calls the entity constructor, then establishes its fields. This gives us the default here, which means this is now having a problem because sprite needs all of the information as well. I think we rework this like so. Then we remove default frame rate. From that, we just let it default, and then we add a void set frame rate. Remove the animation map to the end here, remove the frame rate, and now we are calling the constructor for both these, but we're doubling up on this just because the fact that they are overlapped. We don't need our offset. We have a default for that. We can then remove that from there. We now have text entity should have, oh great, text source position. Visibility is no longer being provided. There we go. Offset is being defaulted. Visibility no longer gets set. We can then set offset. It no longer needs to be provided. We actually provide this quite a bit, don't we? This one might be worth passing along, actually. Button entity. Be text entity. This. Button entity can take that as the default offset, add offset there. Now we should be able to provide a button entity that, given an animation map and all the stuff that a text entity requires, will do everything that both a sprite and text block should be able to do. And comes with specifically idle and select states. That feels weird, but in theory it should do everything. should be good. We are going to have to overload render to help resolve the conflict between sprites render, which we have yet to build, and the text entities render. Uh, we have text entity uses a virtual render. Yep. So we should be able to overload this here. There we go. If we then create a, now let's just do inline here like we did for all the other entities. That is not what we want. So for text entity, if we take the render function and we call render and then we split this logic, actually I even wonder if for this, split this logic out and put it into a bool render text. Just there we go. Okay. We can then call return on render text, providing the renderer and the font, and now our virtual function does the exact same thing, but we now have a render text function that just does text rendering within the container. Return true. Which is important for us because if we do it that way, then we can call sprites render function, which is going to be a bool virtual render. It doesn't need to know that. It just needs the renderer. It will attempt to call base renderer, grab current state from animation map. Animation map should be a, let's use a unordered map. Let's change this to at. No, this is not what we want. We now have our let's do auto frames equals animation map at current state. This is our frames. We know current frame. So we want to grab frames at current frame. Again, we're using at so it doesn't get modified. Speaking of, we should return or set this as const. And we should also probably call this a const. Actually, no, let's not. Auto frame. So this gives all of our frames for the current animation type we're on. We are not specifying our current state anywhere, are we? Where are you defined? Nowhere. Why are you not throwing an error? Interesting. Okay. Well, we do need to know current state. I don't know how this was an airing out, but it's there now. So this tells us, are we currently in the case of our button entity, are we currently in an idle or a select state? We can then grab the frame we're supposed to be rendering, which is this position in that set of frames. Then we need to, which gives us back a rect, which is going to be the position we're using within the texture. And so we need to call, nope, we need to remove this. So we get that. Then we need to set entity renders out based on source. So we need to set source equal to this. Then we attempt to render. We do need to, at some point in time, handle frame ticking. Okay, so this will use the internal renderer that we have configured for entity with no changes. All it's doing is updating the source to be based off of our frame reference. And that way, when we define our sprites, we can just define it as positions within our sprite map. That also means that we can default a null pointer, because this can be null. And if this is null, as we know, that means that it grabs the entire sprite object. So for entities that have a singular reference and no frames, they can just grab the entire sprite sheet, which is effectively what we're doing right now. I do need to go through and configure how we're doing ticking to rotate through these within the sprite, but that's something we'll have to handle later. Our button entity just needs to update this to using button entity.h. We need to import. You don't need SDL. You do need unordered map. Unordered map. And you also need vector for vector. You do need SDL and SDL for our SDL recs. And string. And pair, which comes in from utility. Do we need anything else? Oh, we need font. Which comes in from TTF. This is all coming from text entity, which comes in. Yep, yep. That should fix that. Okay, so now we have all of our references, so this is nice and happy. Our button entity, all it's missing from being fully functional is our animation maps. So if we go to our scene manager where we created our buttons before, CPP file, we just need to provide, what do we call these? Button state. Where we create buttons here, we can return back instead of a text entity, we can grab our button entity, and let's return back a button entity, which will require a new button entity. We just need to provide our animation map, which is going to have idle frames, and we want this to be null, right? Null. This should do the exact same thing it was doing before on idle now. And then we can do the same here and provide it a vector with one entry of null. And now idle and select will both do the exact same thing. And so we should be able to render this out to the screen now. We just need to update scene manager for this to use our button entity. And these need to be it needs to eventually tie back to an entity, which this does. So why are you having a problem with it? Button entity. Entity is ambiguous. Would it help if I button entity? Would it help if I just added public entity here and included? Shouldn't be ambiguous anymore. We officially inherit it. I didn't think so. This multi-inheritance strategy isn't going to work. I could. This is so much boilerplate too to do it. In a perfect world, I can take a sprite should be able to take an entity like, I think. No, because then we run into an issue elsewhere if we're not inheriting entity. First off, let me remove that extra. There. Can I help you, Eggs? You're sitting in front of my monitor. Hey, watch out. Okay. Alright. We have a situation where we need to be able to reference back to both of these structures at different times is our problem. This is expecting an entity object, which in pretty much all of our cases, that's exactly what we want. This is referencing a button entity, which does in fact coalesce down to an entity at some point. Maybe it'd help if we button entity. No, because even this takes an entity. I mean, this is really what we need from all of these is a render function. I'm just trying to avoid having to rewrite the text for the case where we have an animated and a non-animated button right now. That's the only reason that we're going down this route, is because in the case where we have button entities, we want the texture in the background to swap based on a state. That's what all of this is. But we still need to render text over it. In the case of eventually when we need to do dynamic text on the screen, we want to render text out that doesn't have selection states. It's just dumping out text. And so having a text entity that can all its entire purpose is to render text optionally with a background that this is based off of is the main purpose here. The logic for alternating state for buttons is even more simplistic. I was just hoping to avoid recreating how we're doing sprite animations and stuff. Okay, X, you gotta move. Go on. I need to type. Alright. If we remove this, does that solve our problem? It does. What this is telling me is that our multi-type inheritance is having issues. I wonder if, nope, nope, our multi-class inheritance. I wonder if changing these, oops, paste. I wonder if setting this initially instead of the dynamically typed one. I wonder if that will satisfy this. No, it is the multi-inheritance. the complexity for rendering text is way higher than rotating sprites. So this is going to be a text thing. We are going to do that, and then we are going to remove that, or it's just going to ignore that. That's cool. We are going to need to store. All right, so we need a way to update our texture. We don't want to provide texture here. Instead, we want to provide a button state, and we want to provide a animation map, and then we don't want to provide a texture. No, we need to provide the texture. We don't want to provide the source. We still provide a position because that's where we're rendering out to. The animation map is just our map of source textures. And so these two fields combined will provide us that. All right. And so now we can provide this as, we do need to, let's simplify this. I'm going to assume a button only has two states and no animation transitions between them, which will save us a bit of a headache. Let's do this. And we are just going to call this our texture map instead. And then we are going to pass in texture, and we are going to define this as texture map of state. And then we are going to store our private. Give me the using. Yep, yep, yep. We want that. We are going to define our texture map, and we are going to define our button state, and then we need to move our enum above this. Should fix those errors, and then we can reuse this within here, which should clean that up a little bit. And we want to do assignment for texture map, and we want to do assignment for current state. Yep, save that. Text entity is all that we're providing in here, and then we need to overload our render function. And our render function is going to take or set source. So source is provided to us through our inheritance. So text entity should have source on here. Nope, not directly. It's provided in through entity. Okay, protected field, source. So here, we should be able to provide, nope, cannot provide const. Source is set to texture map.current state. So this, every render attempt, it will make sure we are looking our source, which is the area in our sprite map that we're looking at, is set correctly based on the state we're supposed to be in, which will turn back an entity, SDL3. We then provide that through the, we don't actually provide it anywhere. We just update source and then call text entities render, and this handles everything else for us. It's as dumb as we can get it. And so all this is doing is changing the background, and this can already handle rendering backgrounds. And so when we call this here, this problem's solved, but we need to update this to point to null On both these, again, this is changing the area in a sprite map. So the texture provided needs to be a sprite map. In our case, we don't care. We're just pointing to the same area every time. No instance of constructor button entity matches the argument in the list. Okay, so we need to update the constructor. Let's close that and close that. Okay, so we need to take in our button state initially, which is idle. We need to take in our texture map, which is going to link our entries. So that should be good. And then we need to take in the output position. Nope, and the texture and then the position. So texture, that's looking good. And then this is our output position. So this is going to attempt to spread it across the entire screen, which is not what we want. We want this position here. We just got rid of the source because it's being defined here now. Button position, text, and this is our offset on where we want the text within our wrapping element. So that all looks good. Let's do that, and then we should be able to render buttons once again. But we can store selection state. Perfect. So let's change our textures. If we image, let's start with zooming in a little bit so you guys can see what we're doing. If it'll let me. Nope, it's not gonna let me. There it goes. All right, image. We want to change our view area. So let's set the canvas size. We want to decouple that. Let's double the height to 64. We don't want it to center. We want it to, nope, all the way to the top. There we go, and resize. Then we want to, let's set it to black, sure. That should be noticeable. Fill. I always forget the bounding box on this. We need to change the layer size. Scale layer. Nope. We want to edit layer attributes. There's a way we can do this without. Here, let's do it this way. Duplicate layer. U. Select tool. Drag you down. Like so. Looks good. And then that black there. File. Overwrite. That's good. All right, now we're gonna have a problem with our base buttons because they are taking in null. So we need to update this. It's 128 by 32. And then the selected version needs to, this is our horizontal offset and our vertical offset, 32.0. Events is complaining about now. No instance of constructor. What am I providing in that's wrong on this? I assume it's tied to the stuff we just did, which means our texture map. And our texture map should in fact be a unordered map with a button state. Ooh, that's why. Button state. Bound to a, oh, these need to be a pointer. New SDL3 rect. All right, we don't need parentheses for that. Problem solved. Should render what we saw before. Perfect. Okay. And now we can do events or toggle selection. So if we jump down to the scene manager's event handler, not the scene manager, the game manager .cpp. Upload Giddy. Now we have our event handler. We should be able to check to see if the... Why would you recommend Scene Manager handle event? I don't think Scene Manager even has a event handler. It doesn't. Weird. Event. Gotta remember the syntax for this. Key. Then we did a switch on this. And we have the scan code. Yeah. We're just going to find on handle event. Just kidding. We're going to jump down to main. Zoom in so you guys can see this. Let's just jump to our event handler, event type. So if it's a quit event, then we exit out. Here's the ketone. So when we have a key, we do the thing. We want this to be SDLK underscore space. Nope. Yeah, actually we do want that. Space, we just don't want this. Do cycle through options. Break. And then we have we need to do it on release. So what we need here is actually a switch on this. Event type. Now, if you guys will remember, what we need to do is cycle through, or remember, we're doing the one button game jam. So we can only have a single button. So we need to track how long the button was pressed and then set thresholds so that we can toggle between the case where we are holding space and the case where we're clicking space. So if we get this event, then we need to, come on, return on success. So if event type matches event quit, then we return success. We do need a colon there. So that handles that case. Then we've got key up, key down for our different options here. We don't care about mouse movements. Okay, and then in both of these cases, we only care about this. So we want to do if that, we do a thing. And then break. If this, we do a thing. And break. We can get rid of that. And then otherwise we continue. So we want to trigger our actions on mouse up, but we need to know which action type in order to know which to trigger. And so in order to do that, we need to track internally game manager.h. We're going to store a for now, let's just do auto. MS elapsed. This is what we want. Key pressed. No. Space pressed is what we'll call it. And we can store this as a unsigned int. So this is going to be milliseconds since the epoch. If we know it will never be 0 in a normal world situation, so we can set it to 0 and do it. Okay, so if the mouse button, not mouse button, SDL event key up, SDL event key down. Yeah, let's do it that way. All right. It would be nice to also add click handlers. So we could do mouse down, mouse up to function as the exact same situation. However, then we run into this mouse don't trigger this. So we would have to duplicate the logic here. I think what we just do is do a setter and a getter, and then we just duplicate it. I think that's what we're going to do. So we'll handle that in a little bit. Nope. So if the key up, if this is equal to space, we're going to do an action. If, what do we call this? Space pressed. We'll call it key held duration. That makes more sense. If key held duration is greater than threshold, doing this is constant key hold threshold. So if the duration is longer than the threshold, then we have a hold action. Long press, short press. And then we need to close that. And then in the case of this, oh, and then after both of these, so key went up, we do our action, and then we set key held duration equal to 0. Nope, nope. Key hold start. If key hold start minus actually, let's do it that way. Nope, I don't want the whole thing. I want there we go. If the duration is longer than the threshold, it's a long press, otherwise it's a short press. Reset the hold start. Again, remember 0 is our oddball case. And then this, we're just getting SDL ticks, so this event trigger happens, this is time.now. This will always be larger than that, so we do the comparison on it. And then the key down case, if it's our event that we're listening or the key we're listening on, we just need to set the hold start to now. We do need to perform our actions, so let's add some, let's make them protected. We're going to do long press action, short press action. Both of you are going to be void. And then we can just do long press action and short press action. And to test things, we'll just dump out long press action and short press action. Short press, long press, perfect. Let's make sure our hooks are working correctly. If break case, break default break. Cannot jump from switch statement to this case label. Jump passes variable initialization. Oh, it's going to complain about this being initialized inside of here. tap it, short press, if we hold it and let go. Interesting. Key space, key hold, set ticks. It should only be getting cleared here. Should be getting assigned here. SDL log. Let's see what we're missing. Interesting. That was just me holding space. So it's spamming key down event. SDL event. Okay. There's nothing for hold, so we will just check and see if it's equal to space and equal to 0. Let me start. That'll fix it. Tap, short, hold for a second, long press, short press, long press, short press, long press. There we go. So now we have a reference to our scene manager. Let's pop this open. I want to see this. This provides us the full structured list of everything. We don't want that. We want to be able to provide a subset of these that are selectable. We have all the other context, though, that we could do it managed within here. Because we know we have a way to get the current scene. So get current scene. Let's do that. So what we'll do here in our long press action is we will I want to keep the computation as simplistic as possible, which makes me want to hold on to a selection state variable. So let's set a, yep, that. We then want to increment this within the bounds of our context, and then when we change scenes, we leave it. The scene change needs to be handled through the scene manager, but it's orchestrated by the game manager. ensure this is reset to -1 when scene is changed. Is important. We are going to fix this formatting. All right, so we need to know when a, oh, let's grab these. Oh, they're right here, okay. So when we short press, we need to know scene manager, current scene, scene manager. I swear, AI, like 80% of the time, it's not even helping. We want the, let's pop into our scene manager. Let's close this so we have more room, so we can pop this over here and see our reference point. What we want here is we want to get back the scene component. No, we want the entities under a specific scene component. And this is also the short, so this is going to change based on our context. So we're going to have a switch case, and it's going to take in the get current scene, which, if you guys remember, is a reference to the scene manager's current scene. We're then going to have a case for main menu. We just want to get rid of that stuff. Within here, we want to grab the entities under the so we need a function that will return our entities for a given component. So given a scene component, we return our array of entities. So we need to implement this in scene manager.cpp. Where is here? Update to that. That's actually what we want. Okay, so return entities for a given component. Now you'll notice this is a duplicate of what's going on in here. So, but we're grabbing more things. So even though it is a duplicate of this one, well, technically it's a weird offshoot of this, but no, we don't want to do that. I don't want to combine those. I want to keep them separate. We now need to know we know our scene. So let's just grab this and we can call, no, we know what the scene is. So given we want to call this, so it's going to be scene manager, calling that. We want to provide it specifically main menu buttons. We know we want that because we are in the main menu. We now have our reference to the vector, and so we can store that. We are going to grab items at our selected option index, and we are going to So once we hop into here, this is giving us back an entity. We need to, this is an entity reference. Yeah. So we need to, actually we have logic for this that we can grab within the, where a little bit ago. We wrote it in the, it was where we were going through and rendering out chunks. So we need it, I don't think it was in here. Screen manager. Where we were doing this. Okay. We need to grab a auto star reference, nope, auto reference to items. We then want to iterate through these so we can actually do this. And this is, we're just gonna call an item. No, we do want to call an entity. These are the button entities though, and so if it is a button entity, then we cast it off to a button entity. And that allows us to, if we open up our button entity, that allows us to set the, we need to set our current state. So let's void set state. Yep, that. We need to know we don't need to loop through the whole list. What we need is auto items equals, and then we're going to do items items dot at, what do we call our point of reference? Selected option index. This will give us back our reference. We can then store it into the temporary pointer. And then if we were able to store it, then we want the set pointer to selected. Nope. This is now idle. There is no else case for this. And then we duplicate this verbatim. And but before we do that, we do that. So we want, yep, this one is now selected. Is it select? Idle. Just gonna rename that real quick. So we need to increment and then modulus. So it'll wrap. Yep, that works. We have so this will handle our transition of selected and should update the renderer. So we just need to figure out why bypasses initialization, transfer of control bypasses variable items. That doesn't need to be a const. Specifically, we don't want it to be a const. We want to change this so that we can modify it. We're not modifying current state in any way. This is not a const. Get entities for scene component, get entities for scene component. This is returning back our items. Items.at. We are doing a cast on here and we are setting state. Nowhere are we using const. Nope. Nope. Undo. Fine. Const. Get current scene, get entities for current scene. We're not using either of those. We are getting entities for a scene component though, which is not a const. Also not a const. No constant references anywhere. This shouldn't be complaining. Is there a recommended fix? No. Does AI have a solution for this? What an error message. I needed I needed the curly braces around this block. Good to know. Alright, what is this complaining about? We renamed that. Let's see what I missed. Oh. Alright. What'd we break? Out of range on our vector. Right. Because we are doing -1 as our unknown. Let's not. Let's always use 0. You always start with an item selected. That's fine. Doesn't need to be perfect. It's a game jam. Well, that's not working. Set state idle. Set state selected. It should be toggling between these two, but it's not. I'm going to go on a limb and say it's not hitting this SDL log. This is in the short press, right? Yep, okay. It is, in fact, properly casting these to button entities and calling set state on them. Which means something's wrong with our set state. Current state equals state. Current state. We should be able to troubleshoot this. Actually, we can just breakpoint in here. All right. We are getting idle. If we continue to the next one, we are getting selected. Our state is in fact updating, which means we are not re-rendering. Render should be happening regardless. Because nothing in here calls to render, it's constantly running. So if we go to Screen Manager, and we hop down to, I'm going to clean up some of this. Let's try again. Screen Manager, boom. Render frame should just be getting constantly called. Render main menu screen. Oh, this is no longer a text entity. Is it? No, it'd still be a text entity. SDL log. Like I said, it's constantly calling. So, what could be your problem here? It makes me think that maybe we have a text entity does not have text entity does not care actually. So let's try our button entity here. Inside of button entity, we call with the same definition, which should be relying on current state updates. Maybe that's the problem. It was interesting. There we go. We can now move selection. We do, in fact, want to fix the initial render. So when we run, okay, in order to do that, we need to start with our scene manager. You no longer have a default. Current scene can, in fact, return a null. That's going to be a problem. When we do this, I think we can just call a scene transition regardless. Game manager dot cpp. We want upon initialization to call. So let me handle this. Upon initialization, we need to call scene manager change scene to main menu. So when it's initialized, we initially call this. Before that, I think we might need to run. Actually, I have a solution for this that's going to be a little jank. It will work though. We're creating our buttons, popping all of these out. What's the first parameter called? Button state. Nope, nope, just this one. Damn, what did I screw up? Scene manager H. Here we need to remove this, it looks like. There we go. Let's go to our screen manager.cpp and remove this. Get that logging out of the way. And then the last thing we want to do here, let's get back into our game manager. We need to run an identical switch statement. So scene manager change scene. We don't want to do that. So in this case, a selection was made. So I'm tempted to say we're probably fine just adding a clear. We can then, we need to do a lookup. Actually, well, it's a little jank, but we know what index points to what. So this is new game. This one is settings menu. And then we have quit. I don't know what this exit 0 is. It should just be this. So we should be able to exit out of our game. All right. We now have our event handler. I'm going to leave it to do in here. Improve the association between index and action. Because if we were to add another, like our selection is dynamic, it'll just cycle through everything. But if we were to add another menu option, for example, everything works dynamically to increase our menu options, so we can just add as many as we want. However, the logic here is locked to that index. So item 2 will always quit, whether we add more or not. So that's going to be a problem for us. So I think we need to somehow create a association that will allow us to do that. I also noticed that's still there. Do we actually need? It's exit. Yeah. Let's solve that. Quit. Exit out of our program. So this is, we'll close out SDL stuff, and then this will close out our app. Gracefully close out our app. All right. We now have the ability to select options in our menu, which is quite a bit of progress for the day. We've got our scene change. We can now construct scenes and do all of that. So tomorrow we can run through and add our different components for containing cards. We already have the select logic for cycling through them, so we just need to revamp this to where it's dynamic based on the scene that's being passed in. That will allow us to do selection, and then we just need to start adding in the different scene components and card groups. I feel like we can get through a large chunk of our logic, or sorry, a large chunk of our scenes and scene switching tomorrow, just handling using what we already have and then updating this one function. It won't be, computationally accurate or anything, but it would allow us to handle all of our transitions between the different scenes and everything, or at least the majority of the cases, even if we just use placeholders for everything, which will get us in a spot where we can start hopefully sometime tomorrow, at the latest. Nope, right. I will not be streaming tomorrow. I forgot about that. Tomorrow's Wednesday. I need to take my partner to a doctor's appointment that is in a town like 2 hours from here. So I will be gone nearly all of tomorrow handling that. Tonight I might hop on and do a little bit of code to try and refactor this or clean it up, depending on how the next couple hours goes. Tomorrow I might try and hop on a bit offline, and then I guess whatever I can't get to tonight or tomorrow offline, we will pick up back up on Thursday. We need to manage to knock out pretty much all of the selection and transition logic Thursday, as well as get placeholders in for everything um, like Thursday. And then that will allow us to start hopefully sometime Thursday. If not Thursday, then Friday, or really, if we can start adding in our actual logic. And so that hopefully, the goal being hopefully, by end of day Friday, we will have a functional prototype. That's kind of the goal. And so if we can have a functional prototype come Friday, we have, if I remember correctly, until like Monday. Let me check. This is the one button. 21st at 4 p.m. So we have until 4 p.m. my local time on Sunday. So if we can have it in a functional prototype state on Friday, then I can finish it off from there, adding in sound effects, bass music, and we don't have to get like crazy on the art, but better than this. Um, better than that. We can do better than that. So I can focus on that. The polish is kind of the goal. So if we can get it in a functional prototype state by end of day Friday, then I can spend Saturday and Sunday on and off stream in combinations, focusing on getting some polish in so that it looks good. We're also at some point, probably between polish and MVP. Um, so before we start on the polish, I'm going to need to go through and get our what's the word I'm looking for? WebGL build going, so that we can deploy this to their like meet the requirements for the game jam, which is a web build. So we also have to handle that. So just to put this into a spot we have access to, we need to finish prototype. Then we transition into a web build asset. We need to create our itch.io page. Then we want to add polish, and then we want to upload build. Probably going to be something like this. Create a basic itch page, then add the build to it, just so that we can verify it actually functions and works. Add a little bit of polish, create a new build, upload said new build. And then we probably, at some point around here, want to go through and refine our itch.io page. We want to make this look a little better. It's low on importance. I'd rather have a bare bones page with a semi-polished product than a bare bones product with a polished page. You know what I mean? For the prototype, we are going to need to add in scene transitions still. We need to add in card sets. we need to add core game logic, add upgrade system. I feel like that can probably be all we need. We can get away with quite a bit just adding these, I feel like. So that should get us to a functional prototype. When we start on polish, we're probably going to want to start with replace placeholder assets with literally anything. I think the big other polish item we want to do in here is it would be nice to add a. I don't think we're gonna have time for animation on any of this stuff. We've added the base logic for animating our controllers, and we are technically using it for state swaps, but we are not using the full structure for it because we're also not doing the timings and DTs and all that stuff to transition through it. Um, that's fine. We don't want to really start building out animations just yet, anyways, because the time to build assets is going to be our main problem here. I think the biggest win for polish here is going to be expand card options. Adding more content is probably going to win us a lot more than focusing on getting our animations looking good. Like we can get away with testing and on a bare bones MVP with just a handful of them, but to make it actually enjoyable, I think we're going to need a few options. Um, at least long enough to where you can play through and we can start getting to the point of seeing where balance is a problem. Speaking of, balancing would be nice. But overall, we started this yesterday morning. And so, with the exception of like in 30 minutes to an hour of taking some documentation we made and turning it into header files and stuff like that, which we still haven't even used all of yet, um, we've had 2 days on stream and we're already to the point where we need to just start adding in content. So I feel like we're in a pretty good state. It's unfortunate that we're joined in 4 days late, 3 days, 4 days, something like that, after the start of the. I already closed it. When did it start? Itch.io. Yeah, it started on the 12th at 2 p.m. And we started on the 15th. So we pretty much gave up the a full weekend. Um, we did our entire concept planning on the 15th, and we're going to be missing the entirety of tomorrow, essentially. So we're running, instead of it being like, what is it, supposed to be an 8-day game jam or something like that, we're running on like a 4 or 5 day game jam. So I feel like we're in a pretty good state for the amount of time we have and the fact we're not using an engine. We probably could have been simultaneously further along and behind had we used a game engine. Um, I say that because a lot of the stuff we did for like the sprites and rendering and stuff like that, we could have knocked out much quicker. However, the stuff we're going to be doing next, when it starts coming to a lot of these scene transitions and selections and the core logic and stuff like that, um, will be a lot easier with what we've built than it will be through a game engine. So we should be able to start making really good progress on the addition of additional assets, the building of our core gameplay, game logic, the upgrade system, and our when we start getting to adding in non-visual polish, like these kinds of things, it should get a lot easier with what we've built than it would be through a game engine. So we'll have to keep that in mind. But overall, I'd say we're in a fairly decent state. I don't think we're going to get time to go through and handle our multi-threading. We did already handle the virtual resizing. If you guys want a reminder on that, the WebGL we're going to have to handle still. So this will scale up and scale down. And we can do random. So we've got our resizing fixed. All right. We're still going to have to handle WebGL. I didn't think we were going to get to animations. Would have been real nice to decouple this. We have the structure in place. We made sure that as we're going through, we decoupled logic from renderer. The only exceptions to that are our entity objects contain their own render logic, which should be fine because we're using pointers to reference them, but we won't know until we try it. So I feel like overall we're in a fairly decent spot. Of course, I would have liked to get a little bit more time for it up to this point, but it is what it is. Our next ones we will have better schedules on, so we'll do what we can. We have a bit of a downtime, so even though we will be stopping, or sorry, we will be submitting at the end of the game jam period. There's a good chance for at least a couple days after that we will continue to apply a little bit more polish, just to see if we can get it in a better position before we call it quits for Christmas, and then we'll be jumping into our next back-to-back game jams for a little while until we have a majority of a week break before we transition into Pyro software. At which point we'll probably do an analysis and work on whatever we like the most of what we've built so far. So, okay, I think we're good for the day. I just want to commit this, but I can do that off stream. The last little bits we have going on are housekeeping stuff. If you guys are not aware and haven't noticed or seen it, there should be a button somewhere. If you're on Twitch, it'll be down below for our Discord. We do have a community Discord now, so you guys can join me over there, ask questions, reach out to me or other people within the community. You can join the game jam. I have all of the game jams we'll be doing listed in there. So if you guys want to do that, just head over to the Discord and you can find that in the channel. It should be open invite for anybody right now. We'll see how long that lasts and see what we're sitting at there. For anybody who mentioned something and I didn't get a chance to respond to them, I am sorry. Restream was not doing well today. I don't know why. It was perfectly fine when we streamed yesterday. I think I got to everybody that was in Twitch at least. YouTube wouldn't let me see my own chat, which is weird, and Restream wasn't sending it through, which is also weird. So I don't know. I'm sorry. Like I said, we won't be streaming tomorrow, or at least I don't plan on streaming tomorrow. We will be back on stream come Thursday though. So I hope you guys will all join me then, and hopefully we can wrap this up, or at least the majority of it before the weekend, to have a nice easy weekend instead of cramming on a game jam the entire weekend. Alright, I'll talk to you guys later. See you Thursday.